All right, we should be getting started here. Let's see. Let's see how the old stream's looking here. You guys should see everything, and we'll get started here in a second. So, for people that are on the YouTube side, you should be able to see what's going on. Let's see. Twitch side looks good. All right, we'll get started here in a minute. I'm just kind of organizing things, and we're going to do Kubernetes labs. I was asked specifically to do Kubernetes to help get ready for CKAs. Some people want to go take that CKA test. So we, we'll go and look at some of those topics. We'll do some of my stuff. We'll do some of the stuff that's just generically out there on the Killer Coda site, right? It doesn't all have to be my labs, but we'll just work through things and kind of get some of the stuff going and see what happens there. So give me another minute. I'm still organizing a couple of things, and then we'll get right into it. Also, do we have Ranger Cam up? Let's see how Ranger's doing. Ranger should be right here. Oh, look at him. All right. Give me a minute, and we will get to what we're doing for the day. I'll be letting people show up so they don't feel like they're late. And then we'll do all labs Sundays. Yep, Inspector, that's exactly what time it is. Do all the Linux, but mostly Kubernetes, but also all the Linux. All right. What do we got going on here? Let's see. Let's see how my system looks. All right, looks like you guys can see me. I'm here. You guys should be able to hear me. Inspector has already done some emotes for the day, so that's good. Got the emotes going. We are working on Kubernetes because I was asked to. And I got to do a couple of things with the setup of my projects, and I hadn't noticed, or I hadn't thought about this, but my file here actually got, so what happened was in the original Killer Coda, when you used to make these, let's just paste this down in here. What used to happen is you would it would go in the order that you made them, or you could just put numbering in front of them. So originally, like when I made all my Linux labs over here, let me show you guys this. I numbered them so that they would stay in order. But then they got shot up into a whole bunch of different orders anyways, and I'm like, And then I found that they had changed it so you could put this structure.json file, and this file you had to go make it explicitly, but then it would map all your things to be the same thing. So we got to fix it in my lab here. So let's go to, close this out. Let's go to our Kubernetes here, and you'll notice that these start with Kafka in the Kubernetes lab. But that was something I made much later. That was the 1, 2, 3, 4. That was the 5th lab that I made. So that one shouldn't be first. So what we're going to do here, we might zoom out on this a little bit. Oh, maybe we'll just go like this a little bit. So we got a little more room here. And we will clean out all these guys. That's probably enough of them. And what we're going to do is we're going to give them the same name so that everything's the same. So we're doing a little bit of cleanup. Oh god, it's all terrible. Let's name these blue, green deployments. And once you explicitly do these like this, you never have to do it again. So it's kind of nice. We're gonna pick the next one, which is canary deployments, and then we'll go ahead and add this one. And this one will be CKA. Oh, CKA troubleshooting. And then we're just going to copy this one because it's basically the same name on the next line. Boom. Whoops. And it's troubleshooting 2, right? That's what I called this one. Hey, Bottleneck, how's it going? We are just working on, I'm just cleaning up some stuff in the lab and getting ready to do labs. So I'm making some of the labs a little, I guess, nicer. So we'll grab this and we'll do, this one will be Kafka. Kubernetes. And then we'll do this one, which is a MySQL deploy. And by the way, if you mess any of these names up, they don't show up. So you need to make sure that they're all right. All right, there we go. So we'll save this. We'll push it up to our repository here. So we'll say structure for Kubernetes labs. Right, we just do a quick little commit here. I'm glad to catch stream. Yeah, I'm doing pretty good, Bottleneck. We had birthday Friday, so I'm 43 now, right? Getting up there. And definitely up there in the systems space, right? But as far as Linux engineers, I still feel like I'm not super old or anything. I've worked with much older engineers than me in this space, but it's like this stuff doesn't change that much under the hood. So I think there's a lot of value to people that want to get into the industry and don't want to be always keeping track of like the next, software engineering thing. There's nothing wrong with software engineering. There's a big need for it, but not everybody wants to be always learning the new stuff, right? Some people want to be working on systems. There's still a lot to learn. There's no chance that we ever get done learning stuff, but all right. So by the way, what you'll see here in the labs, if we go back to my labs here, we'll see that it just grabbed, it just got the, where's it at? Does it not see me as me? It should show that it just synced today. Yep. So 6:10 because it's on the last, they're on UTC time. So they're like 6 hours, 7 hours ahead of me. So recently updated courses take longer. So, okay, so we know. But now if we go in Kubernetes, we should see them in this order again, which is the order I originally built them in. Or they'll be busted. So there we are in order, and they're all there. So that's good. That means it properly took my structure.json, and now everything in the lab is the way that it should be. So that's what we wanted. We're going to go through, I guess we could do all the labs because I think everything up here has some value for the overall like CKA, and what I'm going to do too is I'll pull up the CKA stuff as we talk through it. So let's get this out of the way. We've got our notepad, so I'm going to start doing, as we go through the labs, I'm going to be building these because I'll update. I was thinking about it, since I'm going to keep making Kubernetes labs, I'm probably going to update the book with the Kubernetes labs as well. So people that have already picked up the book, they get constant updates forever on the book. But I was thinking about, I'm going to keep adding stuff. I'll add Kubernetes labs, and I will also add eventually the Hashi. Well, I don't know if I'm going to add HashiCorp labs. But we'll add something in place of that, but because HashiCorp's kind of, we're not really maintaining those as much anymore. But all right, so we'll get into doing a little Kubernetes tonight because that's the kind of labs that we're going to do, and we'll go ahead and start with. Let's start with one of them that is maybe one of my favorite ones, and this will be the 3-tier application. So this is probably the second most complex lab I have, as far as like being challenging. So I think that you guys should be able to do it. Hey, how's it going, Rossberger? I saw your stream earlier today. You were playing some kind of shooter. I think I popped on there. I was working all day yesterday and today patching servers, so I was kind of busy. I'm going to pin this lab for people. Anybody that wants to do it, this is Killer Coda, and Killer Coda is completely free. So if you guys don't know that, you can go to Killer Coda, you can drop in a shell, and you will be in the same command line interface as I am right here. I and other people in our group maintain these labs here, so you guys can hop in there and do these labs exactly as we do them, right? So this lab is Professional Linux Users Group Kubernetes 3-tier deployment application. And it starts off by saying this lab is part of a larger presentation given to the ProLUG. So in the ProLUG, we have almost 2,000 members now. We've been blowing up, so that's kind of cool. We have... Come on. Come on. God damn it. So we got almost 2,000 members, but I'll show you guys right here. This presentation, if you want this presentation, it's down here under presentations, and it's called Kubernetes Presentation 3-Tier App. So when I say in the lab, it's part of this larger thing. You can go get any of my stuff downloaded if you like PowerPoints. If you don't like PowerPoints, well, that's fine. Nobody's going to force you to like them. But I'll open this up and we'll talk through this. Whoa, it's bright. We'll talk through this a little bit. Here's my ProLUG presentations. Here's my Kubernetes stuff. Kubernetes topics. And this one was building a stable 3-tier app. Yeah, so this one was 3-tier app. Nope, wrong one. Let's get this out of the way. I don't know where. Oh, it must be out here. Oh, it's just 3-tier app. Okay. Give me one more second. So this was the Kubernetes 3-tier app. This was me given to ProLUG last year, right? But I'm not gonna do this one in full screen. This one will be a little smaller here as we look through this stuff. So let me get that up there. And again, if people want it, you got it down in the Discord. You can go grab it. Discord's free. And does anybody link the Discord? There you go. There's the Discord. By the way, I never sleep. Bertrand, I actually got a lot of sleep, man. I worked yesterday. I worked today, but again, patching. The wife came back. I was supposed to be up in Strawberry, Arizona, which is kind of like a nice, like, everybody thinks Phoenix is just, hot and stuff, and it is. It got to 107 yesterday. But there are places outside of the city that are nice and cool in the Phoenix area. So up in Strawberry, about 2 hours north of here, all the family went to a cabin this weekend, and I didn't go because I ended up having to work all weekend. So first weekend in a month or in a year that I've had to work, and it ended up being when we were all going to like a cabin together. So we're gonna do this again. I told you guys I don't care if you know who I am. You can look me up on LinkedIn. I'm a real person. I do have all the things that I say I have as far as certs. But this is a talk through how Kubernetes works, and it talks about deploying a 3-tier application. So in this, over here on the left, there's a whole set of presentation things that you can go read about. Or you can watch, there's a YouTube video that's just this deployment, right? We're here to do the lab, though. So this stuff is not as important right now. We're more focused on the lab right now, which is the hands-on piece. So it says right here, it was given to ProLUG and Redline Performance Solutions. That's who I work for. And it is standalone, but more context can be found in the Discord of the ProLUG group. So if anybody wants to join Discord, you can go down there. We have all kinds of topics on this. But anyways, it says your organization has tasked you with building a modern 3-tier application. We're not devs. We're maybe helping the devs, and they're going to build all the application code. And we're not the database guys, but maybe we're building this in a test environment. We're going to point it back to a real database link later. It doesn't matter. But all the steps are here for us to get to how to understand all that. Ballneck, you're building an Active Directory tutorial. Nice. Are you doing it? Are you doing it in Killer Coda? There's a lot of resources in Killer Coda that are free, guys, for you to either build stuff or to use and learn stuff. So, Gustavo, do you have any advice for beginners on how to start watching your videos? Yeah, I mean, there's a beginners channel or a beginners list, Gustavo, that goes through like all the basic stuff. What I tell people all the time is don't come in here. Like you can come in here and buy the book. People do that, but what I would prefer people do is they join the Discord and go hang out and talk with those other engineers and find things that are interesting to you. Go into the, we've got certification topics. Watch, let me show you as an example here. We were talking about this the other day, so I'm not going to dig into this too much. But you want to get into tech, but you're not doing tech now, and you have nothing on your resume. You don't have, I'm just saying as an example. I'm not telling you exactly. Which mic do I use? I use a Blue Yeti mic. I started using these because DeVry used to use them, and DeVry, D-E-V-R-Y, my college that I teach at. Anyways, it said devour. I've been teaching college for 15 years now, as well as being an engineer, right? But where I'm going with that is I really like their microphones in a classroom setting. So I was like, man, these things are only $120, so I picked it up. Other popular streamers used a Blue Yeti mic as well. I've had mine much longer than I knew about even what streaming was. So I'm not like trying to be like anybody else. I've literally had this mic. And people used to, in fact, a lot of people think that this is a new mic. This has been sitting on my desk for like 3 or 4 years. But it just sat over here off to the side. So I got questions. People were always like, hey, your audio quality is a little bad. So I'm like, all right, I'll just stick the microphone in my mouth and I guess it'll be better. So real quick, I'm talking about this one thing real quick and then we're getting back to the lab. Beginners start here. If you have nothing to put on your resume, here are 5 certifications that are completely free. They're free to study, they're free to sign up for, they're free to take the test, and they give you like a little certification. All of these give you some type of certification that you can go put up on LinkedIn, or you can at least put, I understand API. Like I understand APIs. This one's about there's 3 pieces to this, but it's about maybe an 18-hour course, and then you take all the tests. And then down here, Chaos Engineering. This is from Gremlin, which is a chaos engineering company, and they walk you through what chaos engineering is, and then you go take the test. Hey, Robodom, how's it going? Then Six Sigma White Belt and Lean Six Sigma White Belt. They are statistical processes to improve how things work. Six Sigma deals with Six Sigma is kind of the generic idea of it, and then Lean Six Sigma is almost directly dealing with manufacturing for the most part. But my point is, this is all free stuff that you could go do. And even if you were going to get a help desk position or you were going to get a beginning Linux engineer position, I mean, you could show people what you've done and you can show them your projects and stuff, and that's awesome. But another prong to that attack is getting some certs that are free. And another prong to that attack is maybe going to some school, but not everybody can afford to go to school. Not everybody's got like a school by them or a community college where they can take courses, you know? So these are all things that are free out there for you guys to go use. So the question was, advice for beginners, get plugged in with somebody. And I tell you guys all the time, if it's not this group, if it's not Professional Linux Users Group, because you can't stand listening to me for one more minute, find somebody else. There are so many resources out there that are good. And I even think there's bad resources, but it's still you being as part of a group. So anyways, that's where I would go. Don't just up and buy the book first. The book exists. It's there for labs, but you do not need to do that, strictly speaking. Let me check something. I gotta type something on my other computer real quick. All right, sorry about that. Also, a way to show employees that you're willing to learn stuff on your own. That's true. Yeah, we're trying to kind of. I had a manager early on, and I've told you guys now, I've given over 300 technical interviews in my career now. Like, I'm always being asked to give technical interviews for people. And one of the things that I had a manager early on in my career tell me this when we'd go sit for interviews with people. He goes, hey, Scott, there's 2 things we want to figure out. Can they do the job, and will they do the job? Can they do the job? I think that's the easier part. I can figure out pretty quick if somebody's going to be able to do the job. But will they do the job? Like, can we motivate them? Can we keep them engaged? Are they, are they going to flake? That kind of stuff. That's hard to figure out. So, yeah. Anyway, so that's something to think about. All right, so we're doing this lab. I have it pinned on the Twitch side. On the YouTube side, it was linked, so you guys should see it. And I'm getting kicked out of my system because I've been on over 18 hours today, so that's funny. Shout out to Robodom. You're going to have to be disappointed in my Twitch channel. That's funny. Okay, so let's go through this. Your organization has tasked you to build a modern 3-tier application. What does a modern 3-tier application look like? Generically speaking, it kind of looks like this. You've got a web front end of some type. You've got a logic or application tier where something is hosting an application for you to have the front end feed data into or do whatever we're going to do. And then a back end, you've got a database or a data store of some type. And in our case, we want to have persistent storage. So if these pods ever get killed and started back up, they're still pointing at the same persistent storage data tier, right? So we're going to be, this one's kind of like running. We're going to be, we're not crawling or walking, we're running, right? Using the military idea of, we're not looking at each individual piece, and I'm not taking you to all the docs pages. We're not crawling along and just building what we can. We're going to build the whole thing and think about the pieces as we go. So there's a lot of certified Kubernetes administrator stuff in here, but we're just going to kind of blow through it as we go. Hey, SK, how's it going? Hey, SK, did you get to come to the presentation yesterday by Robbie? One of our guys that's a director of engineering came and talked to everybody yesterday. That's another reason to be in the Discord, is not just to listen to me, but listen to these people that I've worked with over the years or that I've met from doing this, where they come in and they share how they got there. And Robbie's stuff was really good. Man, he was telling people about, I like that it spelled his name right too. He was in talking about how he went from being a junior associate engineer to being a director of engineering and all these other things that he's done in his career. Don't have time to watch the stream tonight, but dropping by. Yeah, Jake Sek, I appreciate that, man. We're just working through stuff, but some people asked for Kubernetes stuff, so we're going to do some Kubernetes. So there's that. All right. So modern application looks something like this, some flavor of this. In my lab, because I'm not a coder and I'm not an application builder, but I can figure stuff out and I could do the basics. What we're going to use is Nginx as our ingress controller. Pretty simple to set up. We'll define those and pass those things through. We'll build at least a read and a test to just send data through. Then over here on the back end, we'll just use Flask inside of Python because it's like the easiest thing to set up in a Docker image, in a Docker container. So we're going to be doing some of that stuff. And then we're going to point it back end to just a back-end database and have that database be MySQL, which is like a super simple structured database. SK, yeah, the stuff that Robbie talked about, yeah, he's in our Discord. Yep, he'll be in there. He talks pretty often. Well, this is his first time talking, but I've talked to him a lot over the years. I've worked with him since actually I met Robbie almost 15 years ago now. So, all right. Anyways, let's get this out of the way. Here's our lab. We're going to build Nginx, Flask, and MySQL to build a proof of concept. A proof of concept, or what sometimes people will call an MVP. Has anybody here ever heard of an MVP? What is MVP? Or a POC, right? So a POC is a proof of concept. Like I can at least put it together, but this is a minimum. That's exactly right. Minimum viable product. Like I want to build something that flows the data all the way through. Can I build something that flows the data all the way through? Oh, sure. We're going to have to up this. This is going to become much more than what it is. But could we build the basics of this? AKA V1. Yeah, that's actually really good. I had never heard about that because I'm Star Fox, the V1, but that's a good point. And by the way, guys, I'm not a software engineer. I'm a CKA and a CKAD, so I understand this from the systems level side, but not the most valuable player in this case. True. But I will show you guys how this works because I think I understand how this works well. And I've had to build these a lot over the years for people because you tell a company a thing can do something for them, and the first thing they're going to do is we'll make it, make it happen once. Like, hey, hold this lighter. This lighter will, light your cigarettes 2,000 times a day. And then they're like, well, okay, well, just get it to light once for me. And you can't even get it to light once. Well, they might not believe that it's going to do the other stuff. So as a technologist, we have to be ready to build the things that we say we're going to build. All right. So anyway, we're going to set this environment up to do the basic things first. Let's do a kubectl. One of the things you may have to do on your Kubernetes exam of any type is see what resources are there. So kubectl get ns will give us all the namespaces. There's a namespace that's only existed for a little bit. It's this ingress Nginx one. Okay. So we're going to have to make the other ones. We'll set up all the namespaces, and we're going to build these tiers based off the namespaces. We're going to do that for a very specific reason that's going to come up in the talk, where when we get down here, we're going to put we're going to build network policies inside of Kubernetes to limit the way that things talk to each other. Okay, so that will be on the securing it part. On the first part, we just need to prove that it works. Then we come through and start locking all the doors and making it a little more secure, right? So set up namespaces, set up the storage, and set up the secrets that we need. So the first thing we'll do is get all the namespaces there, and we'll create the two other namespaces we need, which we need an app namespace for this and a data namespace. That is our logic tier and our data tier behind our front end or web or presentation tier, people call it. You'll hear it called different things as an engineer over time, but a 3-tier app consists of these things. they can be individually scaled and changed without affecting the other components, which is another kind of critical component of these and understanding this from the system side, right? So now we'll get the namespaces, and we see those 2 new namespaces. Good. Boom. Then we're going to make a secret, and the secret we're going to make, I'm going to go ahead and clear the screen real quick. We got the namespaces. There's our namespaces. Good. Let's create a secret, and this is a valuable skill. This is a skill you need to know how to do for the certification, for the CKA, is build a secret of some type. In this case, I'm creating a secret that's called, it's a generic type secret called MySQL, and we're using a from literal. From literal means that I'm doing an imperative command and running it from the command line right here. And it's going to be these values. This is the key value, MySQL root password. And then the password is very secure with a 1 and a pound sign. So it's a 1 and a shift 3, right? And then the namespace that is being built in is data1. So if I do a kubectl get secret -n data1, I should see 1 secret in there. It's MySQL, and it's called opaque. When you make a secret that's just going to be accessed like this as a generic secret, it goes into Kubernetes as an opaque secret. It's just a generic name for it's a secret that I can call. If I want to look at that data, I can maybe read that secret if I have permissions to read it. I can maybe describe that secret and get the data out of it. Or I can actually read it out and decrypt it, right? I can actually pull the data out of that. But for now, we've got it in there. We're going to read it out from the pods later, okay? You may, in the certification, they're not just going to ask you, hey, read that secret out. But they may ask you, like if you take a CKS, they may ask you to read that secret out and then do the base 64 decode to see it. So that's possible. But in this case, we're not going to need to worry about that for now. So we get our secrets and we see that the secret's there. And then we're going to look at a file. I already made this file for you because for this lab to work, we need to kind of blow through it a little faster. But there's 2 things we need to do. We're going to make a persistent volume. And the persistent volume is going to be built somewhere in the system. And then we're going to make a persistent volume claim against that persistent volume, right? So this is the storage stuff you need to know for the CKA. And in fact, I took the CKA a couple times, and you have to be able to build a persistent volume and then get a persistent volume claim from it and then mount it to a pod. So those are all skills you have to be able to do in one of the tests that I told you guys in the test you have questions that you have about 6 to 7 minutes each because you got 2 hours to do about 14 to 18 questions or so. This whole thing is part of one question. So you got to be able to do all this, right? And there's ways to generate these. I have them already built for you, but you can build them at the command line and then push it out, which we're not going to do right now. But the point is we've got these. Let's go ahead and do a kubectl create -f and then give the file, and it's going to create those 2 resources for us. Those resources, by the way, were made in the data1 namespace. Why did we do that? Because if we look at our drawing, our persistent data storage is back here. And you say, Scott, why did we need to build persistent data storage? Well, I said if the pod goes down and comes back up, I want it to reconnect to that data store. In any other Kubernetes configuration, when you're just building pods out there and playing with them and destroying them and building them, all the storage on them is ephemeral. You guys have heard this before, right? It's all ephemeral. All right, so which just means it goes away when the pod goes away. And pods need to be ephemeral resources because we need to be able to destroy and build pods as we want. So we need to know what storage, in this case our database, is off to the side. Now, somebody's going to ask, would you really run MySQL inside of a Kubernetes pod in a production cluster? Probably not. But in a dev cluster where we need to spin this up real fast, without me talking the whole time, yes, SK said no. Yeah, you wouldn't. But if you needed me to just stand this up so you could build your Flask apps real quick and deploy them real quick in that middle tier, we could do this. We would have a place to point it to, and I'm going to show you all that. But we'll go through it. All right, so we do that, and we'll just see that's built. So boom, those are there. And then we'll go look at our ingress Nginx. There's a bunch of stuff in that Nginx place that I built for us out of here, and that's kind of out of scope for this. We just assumed that we had ingress already set up in this Kubernetes cluster. If you needed to see that, you can download the You guys can go to my GitHub. If you're like, Scott, I got to see how you set up the ingress. You can go to the assets, and you can see how I built that. But suffice it to say, what we're talking about here is the difference between the guy like me setting up the cluster for the first time and the guy who's just like deploying resources in the cluster later. That part of it, the reason it's not germane to this conversation, meaning that it doesn't really matter, is because that would be done once on the cluster by somebody like me, and it's not really necessary for everybody to know it. It's also not part of your certified Kubernetes administrator. Ingress is right here. No, that's part of it. The complete one is here. This is the massive. No, that's not it either. Where is it at? Ingress create is here. This is the build of the ingress. It's rather large. It's basically been passed around the internet a lot, but suffice it to say it sets up the Nginx to be able to accept our ingress controller information that we need. All right. So we come back over here. We're going to check a few other things. We got the ingress there. Good. We didn't have to set it up. We're going to do a Docker PS to make sure Docker is up in our environment. And in there, we're going to see this little registry on port 5000. The fact that this is up on port 5000 means that this system has a registry that I can push to, so I'm good. It's got all the things I need. There's one other thing I have set up in this lab that I don't make you guys set up, and it's grep. We're going to call this application lab.mine. That could be application.scottslab. That could be application.prolug.mine, whatever. It doesn't matter. It's just some local application. And that's going to point to 172.30.1.2. So when we set up the ingress controller and we go to test it, we're going to test it against this name with the paths that we set up. And it'll go here. It'll hit the ingress controller on the right path. It'll hit the service on the right path. The service will go to the right Flask application on the path. Flask application will talk to the right data store, and we'll happy dance, right? Everything will work. Okay, so everything's set up on this part. So boom. And by the way, you might notice some of you were like, well, Scott, you keep referencing this. This talk is not about this. This is what we're doing here, the 3-tier application. And this is the things that we're doing, but really we're just doing the lab portion right now. This talk is up in YouTube if anybody needs it later. Minimal vibe product. Yeah. Love the videos. Please keep it up and catch the replay. Yeah. Check code. Hopefully this stuff's useful to you. I appreciate that. Even if you can only stop by for a little bit, people watching this stuff and then going down into our Discord. That's that's the whole goal of this, guys. Get people fed down into Discord. I remember we were just at almost 1,000 people. Like in March, we hit 1,000 people. And we're like, yes. And now we're like right at the cusp of 2,000. So it's kind of been blowing up a little bit, which is pretty cool. I like that because it's not because I care if people are watching this. It's because I know that when you're near other engineers, it will get you doing stuff. So it'll motivate you when you see what other people are working on. It'll give you ideas and stuff. Yeah, Robedom, it's been really popular. Yeah. So it says, now you're ready to set up the application and data portions of the 3-tier app. So we've kind of checked some things, set up some very basic little stuff, but let's set up the data and application portion. I've been talking a lot, so we only have 30 minutes left in this lab. So we're going to create a Flask application and expose it via the ingress controller so we can hit it, and that's going to be a basic test one. Then we're going to create the backend MySQL, and we're going to connect it all the way through. All right, so there's going to be 2 different Flask applications we make. So let's go into Flask Docker. And this will be our basic one. And we're going to cat the Docker file. It's going to pull Python 3.9 Alpine, so it'll run Python. In there, we're going to make an app. We're going to run a requirements file. So let's look at that requirements file right here. And that adds Flask. That's important. You need Flask if you're going to run Flask, right? Then we've got a super simple little Flask application that just calls a render template of index.html. That's all it does. All it does is call it, and it opens it on port 6000 on this box. Okay? Here's what the index looks like. It's a basic little, this is a Flask app containerized with Docker. All right, so you see all that. Nothing up my sleeves. I'm not messing with you guys. I'm not making anything up. Let's build that image, and it's going to go pull all those pieces, and then we're going to push that image up to our local host, that Flask local Docker repository that we have. So this will run. We'll push it up. And this is something you're always going to get an error. That's fine. A little bit of red isn't a big deal. It's just a pip. You shouldn't be doing it as the root user, but in our lab, we're fine with it. All right, so then we're going to push it up to our local repository. So it'll say it's pushed up. And then now to deploy this Docker container that we just built from Kubernetes, you're going to use this. It's a pod. It's going to be called test app 1 in the namespace app. So it's in that namespace app in the middle. It's got the name test app 1. Here's the image, and here's the exposed container port. Well, that container port maps up here to our simple little Flask application listening on port 6000. So everything points to everything, right? So let's create that real quick. Boom. Create that, and it'll say the pod's been created. We can say kubectl get pods -n app 1, right? And in that app namespace, we've got that app that we just built with Flask and push Flask to it, or Flask to it. If you look at this and go, this would be useful to me, please go take any of this. I built all this a year and a half ago or something, and it's like just sitting there. But if any of this inspires you or is useful, please do it. There's so much code out in the world that you can just use to build these things. But now, once we have that pod, we're going to expose that pod, and we're going to do it. This is a task for your CKA. So I've mentioned that all these tasks are for a CKA. We're going to do a kubectl expose the pod test app 1 by name on port 6000 with the name test app 1 service in the application 1 namespace. So that's exposed now. And then we're going to be able to describe that service. And one of the things we should note is the endpoint should have the same IP address. The endpoint that it selected, because its selector is going to select the label that's on that app, should be right here, -o wide. The IP address for this pod that I have not seen before should be 192.168.0.4. 192.168.0.4. It has to. That's what it's pointing to, right? So everything's moving through. The site helps to find the manifest. Core count, you might have to put that in the Discord, and Robodom, I don't know if you mind grabbing it and posting it. But it doesn't come through core count. I apologize. But so we've got that. Now we'll go look at the ingress. How is the ingress going to work? Well, we're going to use the host application.lab.mine, which is our system. We're going to say the path is test, and the backend service that it goes to is test app 1 service. And then the number is port 6000, right? Port number 6000. And when we run that and create that, we've now created from the front end an ingress controller that if you give me a /test when you hit this system on port 6000, I will pass you through to the service. The service will pass you to that endpoint. The endpoint will be listened to on Flask, and Flask will render that simple little index page that says, I'm a Flask application. That's what should happen right here. There it is. I'm a little Flask app. Nothing up my sleeves. You could have a basic little page sitting there, right? Okay. So then, say inspect the MySQL deployment and the service file. So we're going to do the MySQL piece now. This is the back part on the database side. So the database is simple. We're going to grab a MySQL deployment now, and we're going to make the container MySQL 5.6, and we are going to grab an environmental variable called MySQL root password. And this is a special variable for this container, for this Docker image, that when you pass in this secret that we put in earlier as very secure, that is going to be the MySQL password for my application. Port 3306, that's how we connect. And then we're going to mount the path off of that persistent storage, and we're going to use that persistent volume claim. So all those pieces are coming together now as we create this. And then we're going to make a service as well. Oh, the service is already made. The service doesn't have an endpoint yet, but in a second here, when it comes up, it'll be pointed to that pod. Now, I've never seen that pod before, but I'm going to do kubectl get pods -n data 1 -o wide. And does anybody want to guess what they think the IP address of that pod's going to be? That is selected as app MySQL and is probably an endpoint on the MySQL service. There it is, 192.168.1.7. Boom. So you might be saying, Scott, why are you building pods and then building services? Because here's the thing. Pods are ephemeral. Like I said earlier, pods can die, come back. This is in a deployment, so it can die and come back, die and come back. Every time it does that, this service will go, oh, I see the new one. Oh, I see the new one. Oh, I see the new one, and it will change this endpoint. So now my application points to the name of the service, and it never has to worry about what the pods are doing underneath. The software-defined networking that works awesome, but is also turning pods off and bringing them back up. I don't have to worry about that crap anymore. I'm up here with smooth sailing, pointing at endpoints of services. I hope that makes sense to you guys. The idea that I would tell you, hey, come into my pod, come into my application on 192, 168, whatever. I can't even make a thing up for that, let alone you being able to remember it, let alone your static application pointing to it. But if I call it, it's always going to be app.scott.lab.mine. It's always going to be that. And you're like, all right. And then when I give you like a /test and a /read or whatever I give you, you just point at that thing, and everything points all the way through to the pieces it needs to, regardless of what's happened to the pods underneath. Now, if they're unhealthy, that's different. But all right, anyways, okay. I hope that makes sense. Like, it's literally a game of shoots and ladders. You guys ever seen the game Shoots and Ladders? It's literally this game. If you guys ever saw this game as a kid, these things literally just point at other things. You come here, you slide over, or you climb up over here, and then you slide down over here, and then you slide over here. It's all things just have to point to other things. And that's really, I mean, that's a big block of what engineering is. Oh yeah, guys, go to that link for Robodom. Do you mind putting that on the YouTube side? The YouTube side? And the editor.network policy with Cilium is huge. I got to move faster because I'm talking too much. We made the database stuff. So we're going to connect to it real quick. We're going to run a MySQL client on this machine, which is going to run a quick little pod. Well, it's a pod in Kubernetes, and it's going to start up. And I'm just going to run a real quick MySQL connection to make sure that I can get back to that database. This is going to be super simple. I'm in here. I'm going to run this, and now I'm at a MySQL prompt, right? So I ran my command to connect, right, within this pod to that. And then I'm going to go over here, and I'm just going to create. I think I have to actually copy all this, right? I'm going to drop this in right here and paste it, and it will make two entries in a table. So we're going to create database visitors. We're going to create a table persons with an integer for the person ID, a first name of some variables of 0 to 255 total characters, and then last name. So you've got these in structured query language, so it's got to be very structured. And then I inserted two people into it. One is the first guy, first person, Philip Devnall. That is a play on words. And then the other one is Het Tanis. Those are my two users. And then I'm going to go ahead and test that I can read it. Whoops. Do I have an error there? Oh, I have to exit out of this, right? Because you can't do that in the thing. I'm gonna go ahead and test to read right here, and there's the read. Can't read while you're still in the MySQL. But from this, I can just do a very simple read and select every value from persons. That's a very simple little thing. And if you're like, I don't know any SQL, you just go to W3 Schools. Right? W3 Schools will set you straight on how to start SQL. And then you can go spend the rest of your career being a SQL guy if that's something that's interesting to you, right? But they've got all the stuff here. And one of the things that they're big on is teaching you how to do SQL. In fact, I still reference this place sometimes. I don't even do SQL, but I can do enough in there to be everything that I need to be as the part of engineering that I use. Yeah, and Robodom's a professional, and he goes and uses it. So it's important. All right. So we built that. Let's leave the client so we get out of there. We'll get back to our normal shell. That pod is gone forever now. That client's deleted. And we're going to build a read application. So we're going to change over to the Flask read Docker. And let's compare this to the first one. In this one, we're still using Python 3.9. We're still using app. But now our app is called read.py. So that's important. Entry point is still Python. All the other things are the same. We've got a different requirements file. Because in here, I put Flask. But I also have you do PyMySQL because we have to read from a MySQL connector. So we need to have we have to be able to import the libraries for that, right? Or whatever they call it. I think packages, right? Packages or whatever they call them. I think that's right. Anyways, so we're going to, I don't know the terminology for that, but there's our requirements. here's my application, super simple little application. And in here, I did something we would never do, guys. But I did it to show you that when I go to connect, I would normally never put the connect string. I would grab that from a secret inside of Kubernetes. But I did that to show you that the MySQL service is very easy to call if you're in the same namespace, but this is over in app 1. It's not in the data 1 namespace. They're separate. So to call him, it's like calling my buddy. I can't just stand in my house and say, hey, Robodom, how's it going? I'm never going to hear from Robodom. But if I call his phone number, or if I call him on Discord, I can reach Robodom. Does that make sense? So I have to call, so I'm trying to reach the MySQL service, but it's in the data 1 app, and then this is a default service.cluster.local. If you don't change it, that'll be default. But if you do change that for your cluster, that'll be whatever your internal cluster DNS name is, right? I said users root. I put the password very secure. I would normally not do this. This would also normally be read in as a secret, and we could just pass that in as an environmental variable, and it would all be good. But I wanted to show you guys, I'm calling this out. We would normally not do this. Also, you could leave the root user out and have different users be used, and the database could be different as well. So then your different app teams, if we turn these into variables, your different app teams can deploy and call different values out of here. But anyways, my point in saying all that is we're going to then go select everything from persons in that database, and then we're going to put the results into our index.html. Super easy to look at that over here. It's going to just do 4-row in results, and I predict that this will tell me 1 is Philip Devnall and 2 is Het Tanis, right? Those are the two values that are from our database over there. So let's build this real quick because we only got 24 minutes left of our lab, right? We're going to build the image. It's going to pull it down, going to put the requirements into it. It's going to do all the things. We'll get that one error because we're pip as root. Who cares? Yeah, there you go. Boom. But we got it all built. We're going to then push that up to our local repository so that Kubernetes can pull it. That's why we do that. Push that up. We're going to create that pod, the read app 1. And we also created the service right here. We're going to create the service where we expose it on port 6000. But now it's going to be /read. Well, we'll get to that here in a second. But it's read app 1 now, right? Read app 1 is a service. And it's read app 1 service. Okay, good. So we'll go look at it. And out there, it's a .5 and a .4. For the read is the .5 and the .4 is the old test one. And then now we're going to go look at the new ingress. The new ingress is going to have test going to test still, and it's going to have read going to our read service. They're both coming in on port 6000, but they're switching based on what path you give it. There's also something that I have right here. This is very important. Did you guys notice that in my application assumes that it's just a /? My application doesn't have any pathing to it. Did you guys see any in my Flask application? No. In fact, in my Flask application, it specifically says you're just coming in as /, right? Watch right here. Your just app route is right here. What this means right here, this is an important thing to know. And you don't need to know this for the CKA, but you do need to know this for your CKAD. This rewrite target to / means it does not matter what you pass in here. The back end is always going to see a /. And you say, well, why does that matter? Well, what if some team controls this ingress and like 3 other dev teams are over here and they keep having to ask, well, okay, hey, when you go ahead and put that path through, can you make sure that you have the right full path to my app? I say, no, I'm just going to send it to you and you can deal with it however you want from root of your application. So that's a design decision you have to make as engineers, and that has to be something that we talk about, right? Which Hunter Bravo said, may I ask what's going on here? I'm interested in cybersecurity and ethical hacking. This is, we're building Kubernetes, and we're getting ready. Some people are getting ready for their CKA inside of our environment. So I'm going through a lab that I have. The labs are free out on Killer Coda, and this lab deals with building a 3-tier application. So, okay. Thought this was a stream for unethical hacking. Oh, man. Okay, so let's expose that. Let's get the pods. Let's describe the service. It should point to that correct pod. We can go look at the services or the pods again if we need to verify. But yeah, read is pointed to read. And what we're going to do then is we're going to just go ahead and destroy that old ingress and deploy the new one. So we destroyed the old one, deployed the new one. Okay? And then now there's 2 things that we should see when we do our curl. we should see the original test, which was just a test of a flat page. And then this application read, if we did this right, we'll hit the front-end ingress controller with a /read. It will strip that off, and it will pass it back through. It'll go to the service for the read in the app1 namespace. That application, if it's all configured correctly, and if the backend MySQL is working, will go and it will read the MySQL through that connector. It will pull the data back. It'll generate the HTML page, and then it'll present it back to us, if this all works. This is still hacking on how to do K8s. Sure. Hacking in of itself is just the idea that we send inputs into a system until we get the desired outputs and understand the system. That's all hacking is. Hacking has very little to do. In fact, hacking has nothing to do with getting into systems. Cracking is getting into systems, and hacking itself is part of engineering. So this first one was, go ahead, that's still our basic little app. But now down here, it read 1 Philip and Devnal and 2 Het Tanis, because you didn't see that in my index, or you didn't see that in my HTML earlier. That had to be generated, guys. That had to be generated by pulling data all the way through. All right, so we did that. Boom. Now we need security on our app. There's 2 ways that we can be more secure in here. One, we're going to make some application decisions about how things talk within our namespaces. So down here, I'm going to pull this. I'm going to make this big for a second so you guys can see it. We allowed everything to talk to everything originally. That's actually one of the tenets of Kubernetes. There's no questions on the CKA, but you should know that if there's no network policies in place, everything can talk to everything in Kubernetes. That's actually, again, one of the tenets of Kubernetes. Everything should be able to talk to anything as long as it can properly format a call to DNS. We are going to change that. We are going to secure it. The only people that can talk to our database servers now are going to be coming from app 1. And we're going to prove that, right? We set things, we prove them to ourselves. We set things, we prove them to ourselves. We test our hypotheses and our good cases, and then we test our null hypothesis and see that things break, right? This is, well, you never disprove a hypothesis, you only prove your null, right? I'm only studying the old school MIT CSAIL definition of hack. Fair. Okay, so over here, we're going to set this up. I'm going to do a talk later on when I build out our whole like just systems engineering thing. I'm going to enumerate the differences between the types of access and access controls that we see. But this is Kubernetes does it in a completely unique way compared to network access control lists and network security group and all these different things that you can do inside of systems. They do it differently. They have the ability. So right here, I'm going to deny everything into the data one. And if you did that in a policy for like identity and access management, like in the cloud, you would then have stopped anything from ever getting in and it would never change. But it's almost like when we when we allow one thing through, so anybody coming in to 3306 from the app1 namespace, we're going to allow from the namespace selector app1 in. But you say, wait a minute, Scott, didn't you just stop everybody up here? And I say, yes. However, there's an aggregation in Kubernetes as it applies network policies. And if something punches a hole through, it does override a default deny. Other types of filters and ways that we access control things do not behave like that. So you have to know the differences. We put a veil up. Nobody can get data. Nobody can ingress my controllers if I only do this one. My backend data is locked so much that nothing gets in. But then I punch a hole for app 1 to come through on 3306. And you say, well, hold on. What's the order that it's applied? It's aggregated. All of them are applied at the same time. And the rules are all evaluated at once. It's not like, so you say, I know access control lists, Scott. I know that if I hit a deny policy, I'm denied and I don't get to go further. And I say, that's true in network access control lists and access control lists and in your Cisco world. That's not true in Kubernetes. In Kubernetes, they lay it over the top. And they go, you know what? I see a little bit of light shining through there for 3306, but only on app 1. I'm going to allow it. And it's like that guy going, I'll allow it, right? All right, anyway, so those are our two policies. Let's apply them both. So we'll create the first one. We'll create the second one. We've now locked down all traffic into data 1. No traffic's ingressing there anymore. And then we punch that one hole through for the app 1. So our application should still work right now. But the other one is that we're going to test this and prove to ourselves. So I'm going to say, did we break everything? We didn't break anything. I'm still reading data all the way through. There's no caching. You guys didn't see me build some Flask application that like back end caches shit. I don't even know how to do that. I probably figure it out, right? Like I can figure stuff out. I mean, that's one of my skills as an engineer, but I don't know how to do that. That is reading in real time from the database right there. So I'm going to come down here and I'm going to run another MySQL client, but I'm doing it in the normal default database. So this is the default database. And if I'm in here and I try to collect the information from that, this should sit here and never get through because I'm in the default, not in app 1, and I can't read that. We'll give it about 10 seconds. It's not going to time out. It'll sit there. It might time out after some long timeout, but it's going to sit there for a while. I don't know what the client default timeout is, but that's no good. So let's get out of that. That pod will be gone forever. And let's run the exact same pod, but in the N1 or in the app 1 database. And in here, we're going to run the same exact command again, and it immediately read it. So that to me, look, that was, we gave the other one like 15 seconds, right? We're still in a different app or a different namespace, and we're still using the long query here to get over there, but the one in the default did not connect through, and this one did immediately. So let's exit out of there. We did that. That's secure now. That's more secure because only one way in. And then we come down here and let's delete the pod to read things. And let's look at the secure version of my read. And the secure version of my read looks just like my other one. It's still a read app. But now I'm going to run as user 1000. Who's user 1000? That's Ubuntu. That's some... He happens to, in this network, have admin. But he probably wouldn't in a normal system, some user at 1000 or I could define a user, I could just make up a user and point it to him and he wouldn't have root. But also down here, we have a security context, allow privileged escalation false. So this user cannot become root if he wants to. And then here's another one. This is like the, right. This is like the chef's kiss or the little Italian thing everybody always does. This is read only root file system true. So my application that was loaded up and then we enter it as read.py and it runs, that is like, it would be like if I grabbed this right here, this little plastic here and try to scrape it with my fingers. I can't. If I got a knife, I could maybe do it, but the point is the file system can't be changed. If you can compromise this process that's running, if you can, you're still just a generic user that can't become root and you can't change my application in any way. OpenShift generates. Oh yeah, so OpenShift does it with a probably even more secure way. So let's go ahead and create this new one, and then the real test is, does the read still work now with those security things in place? Again, I told you guys everything we do is kind of like an iterative process. Yes, I was able to read all the way through, and how did that work? That was again, if we look at let's cat our back here, our ingress. For the complete app ingress, we hit read on the front end Nginx over here. Where's he at? Right here. We hit the Nginx ingress controller on /read. That's what our curl did right here. This curl right here said application.lab.mine and hit our box on /read. So when it did that, it hit right here. That ingress said to go to read app 1 service. Read app 1 service is over here hanging out in app 1. And that hits down to our pod that we just removed and re-added. When it removed and re-added it, it got a new IP address. I didn't call this out. I mentioned it earlier, but that service pointed immediately down to the right pod. So then when that service read that pod, which now is the only pod that's allowed to read from our database, went and read the database by getting through that network policy, and it read, and then it gave us back information that it read out of that database from our simple little table. So this is a 3-tier app. This is a working, functioning, pretty well locked down, because nobody can mess with that database right now. I mean, you would have to compromise this one app container that we locked down pretty well. So we came in here and we added immutability, meaning you can't change, or what we call a immutable root, right? And then, no root, so you can't become root, and then immutable root file system, so you can't change it. And then allowing this over here, all the pieces are as they should be, right? So that's that first application. That's that first And that's a lot. But there's all kinds of pieces there that come from the Certified Kubernetes Administrator test. And there's all kinds of things there that individually kind of touch different pieces that you might run into. So I kind of wanted to get that in there. Yeah. Suresh, if you get stuck on anything, if you go, I have all these live things that I throw up in YouTube, guys. But if you miss any of this stuff, or I'm always doing like live presentations. I have 3 things that are out there that were recorded, and I think they were recorded well enough to like have up there. And one of them is this 3-tier application. So the whole entire talk from start to finish is going through this presentation. Again, I'm not going through the presentation right now. I'm just showing you the diagrams that exist out there. And again, this is in our Discord, so if you want it, go take it, right? Okay. So that was almost an hour. We got all the way through to the end. We check it. It says, look at you learning Kubernetes. You solved this challenge and created a secure 3-tier application. All we had to do was proof of concept for our boss. And you might say, well, Scott, hold on. You did that in an hour, but you spent some time before. Yeah, I spent some time prepping that. But if that's useful to you and if you need it, go take it. You can take it right out of the lab, or you can go get it from my GitHub. It's in the Professional Linux Users Group stuff. So there's that. Okay. All right. We are just over an hour on the actual stream, so I'm going to put on Ranger Cam real quick, and I'm going to take a break. So here's Ranger Cam. Here's how our labs are going. Hold on. Let me refresh some of this stuff. Here's Ranger Cam. Oh, Ranger's not even at his cam. Where's Ranger at? I don't know where Ranger is. But we're going to loop through everything, and I'll put my little hourglass up. Take a break. Stretch your legs out if you want. Where's my little hourglass at? Boom. There's our memory usage for the last 30 days. Normally I keep this at 7 days, don't I? Normally that's 7 days. Come on, 7 days. Boom. All right, I'm going to say break and Ranger check. And then we'll go 8 minutes. All right, boom. There we go. So I'll be back. Take a break, smoke them if you got them, whatever. I don't smoke, but, that's what they used to say in the military. So, look at all the people trying to log into my systems. All right. I'm still on break, but just so you guys know, if you guys do those labs and you ever get stuck, just let me know where it was at in the discussion. You can clip it, or you can send me the timestamp in YouTube. We've got a channel in the Discord. See, I gave Ranger a treat. We've got a channel in the Discord, and you guys can ask down there, and I will try to answer anything or walk you through stuff if I can. So, if you're watching this later and you're like, "What the hell was that?" I assure you, there were no tricks up my sleeves. I'll be back. Let me eat my pizza from earlier again. Ranger's got to get every last crumb off that bed. Look at him. That dog. We love Ranger, but man, he's got to eat every piece. All right. Let me chew my pizza real loud in your ears. But again, yeah, let me pull this up while we're talking here. In the Discord, we've got a section here called Twitch and YouTube questions. So, yeah, people have been not asking questions, but you're welcome to ask questions. If you get stuck on anything, or if you're part of the Discord or you're not, and you just want to come in there and ask something, just clip it or timestamp it and let me know so I can go reference what the heck I was talking about. And I will try to help you out in any way I can. All right, 2 more bites, 2 more minutes of break, and then we'll go. I also got a drink. Yeah, Robe Dom, I'm going to try to get Robbie to come back for our 5-year anniversary. All right, so this lab's about to die. We're going to step out of this lab. I'm going to repin a new lab for you guys. And we're going to walk through the piece that's actually the piece before that. So I did all that to kind of get you guys, like, I don't know, get you guys as much into it as we could. Go ahead and stop the thing here. But that kind of dropped you in the deep end. Now we're going to walk back a little bit. And when we walk back a little bit, here's the lab. I'll pin it for you guys over on Twitch. On the YouTube side, I don't have any facility to pin that I know of. But we're going to do just the piece with the data. And in this case, we're going to use MySQL. And I will eventually be adding more database. I just haven't had time with all the other stuff I work on. But suffice it to say, the steps that I've built here, you could probably just add. If I could get this, I've got something on my keyboard on the 4, so I can't. Oh well, whatever. We'll leave it. But what I wanted to tell you guys is, you could set up what I'm going to do here, and then you could use almost any type of database container that you wanted. I'm going to use MySQL because that's one that I'm pretty familiar with. But if you wanted to point it to Cassandra or Cockroach or, I mean, there's Postgres. There are all kinds of things that you could put it. Robe Dom, it was pretty good pizza. We actually had pizza earlier. Oh, no, it's not on the 4 key, though. No, me and the wife had pizza and wings earlier. We really wanted the wings. And we didn't eat all the pizza, so I was down there munching on it during my little break there. So. Also, why does it say... Oh, there it is. I apologize. I might have missed some people following. Flat DJ Black. Hopefully this stuff's useful to you. People on the YouTube side. It doesn't even show me when people follow on the YouTube side or when they subscribe or whatever they call that. I don't know. But let's just focus on what we can focus on. And this one says Kubernetes MySQL deployment. It says your organization is going to start building out 3-tier apps. Well, we just did that. The weather's like 100 and something. It's 100 degrees and like windy right now. It's 103 right now, actually. So if anybody wants to turn that into Celsius for people outside of the U.S., it's hot. It's hot in Phoenix. So you decided that you're going to do the MySQL piece of this. And you decide to deploy MySQL in the Kubernetes cluster. So we'll create a persistent volume and a persistent volume claim to store our MySQL data of at least 10 gigs. Our test data is 8.5 gigs, and we just have to be able to reach it and look at it and write the data in and all that kind of stuff, right? So the first thing we're going to do is we're going to generate a secret password. Again, this is exactly one of the steps that you need to be able to do to pass your CKA, being able to load data as a secret and as a configuration, what are they called? Configure map, right? Configuration map, which can, by the way, be files. In some of our labs, we do config maps as files. But being able to do that is good. And let's say I didn't know how to do that. I can say cube create secret, and I know the name I have to give it, but then I can say help. And it'll come down here, and it seems like there's a lot of info, but I just want to show you guys this one thing. Right near the top, and guys, you can use this on your actual test. Here are examples that are pretty close to anything that they can run into. Flat DJ Black, you're learning and newbie in DevOps. That's awesome. It's a good place. I'm on the platform and the systems and like the Linux engineering side of things, but I touch so much DevOps that while I don't call myself a DevOps engineer, I mentor DevOps engineers at work, right? Like they're always asking me stuff, mostly about the systems and stuff, but in general, I do a tremendous amount of automation in general. But that's why we have so many labs on Ansible, because Ansible is my tool of choice. If you said, hey, Scott, you can only use one tool, it would be Bash. And then if it was only 2 tools, it would be Ansible, right? Because I need Bash to do all my Linux, right? But outside of Bash, it's definitely the next thing is Ansible. That's just, me. All right, so then let's go look at the information around the SQL, and we're going to make some persistent volume, one persistent volume. It's going to have 10 gigs. It's going to be read write once, and it's going to be off of the host path of mount data. That just has to be there in the environment that's already been set up. And then a persistent volume claim will be made against that as read write once as well. And then we're going to be able to mount that persistent volume claim as a volume to one or many of our pods, depending on how you have it set up. There's actually new access modes that I haven't even learned about because they came out in later versions of Kubernetes. I think I took the test in like 1.24, and I think 1.30 was just released. So like I have to go catch up a little bit, right? There's a lot of that stuff. Suresh, just so you know, SK, I don't admit to this often, but I do have PowerShell in our Discord. We're a professional Linux users group, but I do have, if you go to our server and you go down to our, I think it's under, no, it's here. It's the old way of doing things. And you go to off-topic resources and you scroll that all the way to the top. All the way to the top. It's all the way up. As far back as it goes. You'll run into all of my, this is even before this stuff, all my PowerShell challenges. So I don't do a lot of PowerShell, guys, but I have trained engineers in PowerShell over the years. And I take it back. I used some PowerShell to configure Windows devices, but I almost always still pushed it with Ansible. Ansible was my controller. Ansible was like the one casting the spells and doing everything, and then the PowerShell was just being pushed to the machines and running. So, but that we don't have to go into that too much. And by the way, you might say Ansible can control Windows. Absolutely, Ansible can control Windows. You have a WinRM, which is Windows Remote Management. It's port 5985 and 5986, and it's fantastic. So it's a really good tool. 5986 is the secure one, and you got to use certs for that. But 5985 is just open, and you can actually use authentication through if you have like service accounts or something in your organization, you can do that. But yeah, I do have PowerShell, even though I don't really advertise that much. So we saw that. Let's create it. And the kubectl crate-f is really, really important. You need to understand how to create something and modify it in some way for your test. I'll show you guys some tricks for your CKA and things that you need to know as well. But now we can get our secrets. There is a secret that we've made, and we can get our persistent volume and our persistent volume claim, and we see them, and we see that they were just created a few seconds ago, right? We can describe the secret, and the secret will come out to us here. And then we can get the secret. Actually, it's funny, I didn't do this in the 3-tier app, but I was talking about this. You can actually run this command to get the secret, but that is not the secret that you guys saw me put in there. Right here, you guys saw me load this secret up. It's up a little bit more. It was very secure, right? It was very secure. You guys saw me load that up. That's our very secure lab password, right? But then you come down here, and that's not it. But there's a reason that that doesn't work. It's because it's a base 64 encoded thing. So what you actually have to do with this is you take that output, and it's going to give you this base 64 encoded thing, right? And what you do then is you take that and you echo that base 64 encoded string. You paste it if you want. And then paste that through base 64-D, right? And that will give you back the very secure there. See that? Oh, and they have it right there. Oh, yeah, I didn't even realize I had it. -D or -D code, whichever one fits your fancy. But you notice I don't make this one execute. All the other things are executable in the lab, but this one's not, because I can't just have people pushing the button and then sending me messages like, the value from above doesn't automatically grab the value from above, and you're just like, oh, mother effer. I know it does. You're like, all right, I'll be good. Oh, look, I can say that. It won't let me say the F word. Well, I can say whatever I want. It won't show up down there on my closed captioning. So, also, I'm surprised nobody's asked me about closed captioning in a while. I normally get one of those or two of those a stream. If you're wondering about the closed captioning, it's simply PowerPoint behind everything. PowerPoint's got a pretty good little. I mean, if you don't mind. I mean, we're already loading everything up to the internet, so who cares? But that's also being tracked by Microsoft Azure. Microsoft runs everything. Ow. My elbow popping, in case anybody wondered, in case you heard that. That's a thing that happens when you do jiu-jitsu for 20 years. All right, so let's check this out. We've built the first part. Now we're going to create a service that exposes the MySQL pod to the internal cluster on port 3306. We'll name it MySQL-service. Then we'll create a pod that runs a MySQL pod that's listening, or create a deployment that runs a MySQL pod that's listening on 3306 and ensure that all those resources come up. Microsoft will catch on to my swearing. Yeah, that's true. Let's go look at this. So we're going to look at our MySQL file. This MySQL file, by the way, is the same one that I made earlier in the other lab. I actually stole it from this lab for that lab, or that. I think it was this lab first and then that one. Yeah. And there's that. And it said, you may choose to write your own deployment or service if you're preparing for the CKA or CKAD examinations. In that case, make sure the service is named MySQL Service. So you can make these yourself, is my point. You didn't have to go through my actual making this. But you do need to understand these pieces for the Kubernetes piece, so or the CKA. So if you're telling me you're going to take this test, you need to be able to do basically this right there. I'm going to show you guys how I generated this. You need to be able to do a kubectl deploy. Kubectl. Yeah, it should just be run. I think it's run deployment, right? Like that. And they'll say, the flags aren't set. So we'll say run deployment, and we'll give it a name. The name will be, in this case, MySQL, let's say. And then the image will be equal to this image right here, right? And then we'll give it the number of, we'll give it namespace if we had a particular namespace for it. But in this case, I didn't give it a special namespace. Yeah, it's just in the normal. We didn't put this one down anywhere special, like in a data one, like I do in the other lab. So okay, so we didn't do a namespace, and then the replicas equals 1. We actually only wanted to create one. Oh, replicas. Is it not replicas? Is it scale? Maybe that's. I thought it was replica. Do I not know how to do that anymore? And then, by the way, we're going to do -o YAML and -- dry run equals client. Replica? Replicas. I thought it was replicas. Maybe that's not right. Anyways, the point is you could build that. I don't know. I haven't done this in a while. Should be run deployment. Maybe it's create deployment. All right. So there. Anyway, yeah, that's what it is. It's run if you want to just run one pod. I was having a brain freeze, I guess. So now, we have that, and if I wanted to, I could throw this into temps, Scott deploy or whatever, SQL .yaml, right? And then now I can modify that in whatever way I need to, right? In here, my container needs to mount that persistent volume. So I need to make the volume and read the persistent volume, and then I need to make it available here, right? So I could go figure out how to do that. If I didn't know how to do this, I can go figure that out inside of the documentation. That is a long process. That can take us some time to figure that out if we needed to do that. So one thing I would advise if you're taking the CKA is have some of these things kind of bookmarked in your head. You're only going to be able to go to Kubernetes.io, right? This is the only place you're going to be able to go. Kubernetes.io and then documentation here. This will be the only place you can go when you're in your test. Well, for the most part, I think you can go to Docker and you can do some other stuff, but this is really it. And in here, you're going to need to say that I need to persistent volume claim pod, right? Or something like this. And then you'll see configure a pod to use persistent volume storage. Okay. But here's the thing I haven't worried about. I haven't worried the structure of building a pod. I know that part is going to be a deployment with one replica of MySQL. I've got all those other things ready. I'm going to pull the right image that they told me to. Now all I got to do is this other part, which down here, we've got the persistent volume already made. Don't need to do that. I know its name. And then now, okay, I've got to make this volume mounts thing happen. I know that. And I need these volumes thing to happen. And then all I got to do is go change this. Look, volumes needs to be at the same layer with my containers. So I come up here to where I'm at containers right here, right? It's got to be at the same level as this. Oops. Thought I had it copied, right? And you got to do this stuff kind of fast. Now this is a pod example. We're not doing a pod. We're doing a deployment that deploys a pod inside of here. So for me, I need volumes at the same level as containers, and then everything else needs to be YAML compliant, which looks something like that. At the minimum that. I guess it could be this. Right? They just have to be spaced the same. But now my volumes have to be the right names though, right? So the name isn't task PV storage. And by the way, I need to generate my volumes first. So over here, volumes are, volumes are at the same level with that. And then my volume mounts are at the same level with my image as I come over here, right? So I go down in here now inside of my container definition, I can drop my volume mounts, right? And actually, one thing I might want to do here, volume mounts, mount path, I'll probably line that up. Check this out. Name, image, ports, volume mounts. Yeah. Containers, name. And then you can go in here and you can, oh yeah, they have that backwards. But the point is, you can set this all up, and when you're done with it, you're going to get pretty much the same thing that I already have. Again, mine, you know. You're going to get basically the same thing when you're all done. Then there was another thing I was going to have to pull in, which was my environmental variable from a secret. So I have to come over here, and I have to say pod secret, right? And then how do I secrets, and then if you want to access secret in a pod, you can do it there. Let's see. Yeah, probably just this top one, right? Then you have to go down here and find where it says how to use secrets. And it depends, I mean, it depends the size of the window you're looking at, kind of. But they have some other ones. So I want to call this in as an environment. What the hell's going on here? Another follow, something. I don't know. I don't know what's happening over there. ENV. ENV, guys. Here you go. You want to pull in an environmental variable, right? Anyways, the point is you come in here and you figure out how to get the stuff to mount. And I would not be going in there. Like, if I was trying to figure this out, I would not be going in here blind. I would have practiced this stuff, right? So you need to be ready to do this in a quick time when you go for your CKA. This is one of mine. Obviously, when you can do it at your leisure, you're going to spend time and grab it. But in this case, I just name an environment, and then I say that this is the name of the variable. By the way, that works directly with the Docker image. So if I were to go to Docker MySQL image, right? And I were to go to the official Docker Hub image, and I were to scroll. Oh, motherfucker. I come down here. They'll give me how I could run it. But down here, they'll give me the exact variables that I can set. Here, if I want to set a mandatory, well, it's mandatory, so I don't want to, specifies the password that we set in the MySQL root super user account, and it was set to, in this case, MySQL password. They're handing it in as a Docker run, but we're using Kubernetes to deploy a pod, and that pod happens to have a Docker image in it, so we have to pass the variable all the way through to that, right? But here's all the variables that you're going to use. So you need to understand how to put your variables into your pods as well. All right. So anyways, we create it, and then we look at the service, and the service doesn't have an endpoint yet because it's not up. But if we give it a second, there, nope, still not there yet. Still not there yet. Now it's up. We haven't looked at the pods yet, but I know that pod is going to have an IP address of 192.168.0.6 because that's the only one that could possibly be the back-end endpoint to that. So there you go. Hey, how's it going, non-major nerd? We are hanging out, and I got some questions around Certified Kubernetes Administrator, and I was just going through some labs that I have. By the way, my labs on here are just kind of to get people doing Kubernetes and looking at it as like an enterprise tool. There are like 150 labs just on Kubernetes. So if you were like, hey, Scott, I can't stand another minute of your labs, fair. My labs aren't for everybody. But here's all the CKA certification labs that are out there, right? And there's 20, 70, that's at least 120 right there. Because that's 100 and another 20, but it's plus because there's more. So that's a pretty fair amount of labs to get you into there. And this guy with 70, some of his are exactly like the questions on the test. And when I say that, I'm not saying like he's cheating and giving you the questions. I'm saying he gives you it and it looks a lot like the test questions, even though they're not the exact same questions. But he goes over all the different things that you need to understand. You need to know how to make a network service policy. And, I can't go in there because I'm already in one. But if you do Killer Coda, that stuff's really good. I would get as much hands-on time as I could and try to not look at the answers in those labs, right? All right, so anyways, my stuff's all running, and I say that's good. Now we've got MySQL up, and there's a service, so let's test that we can connect to it. So we're going to run a MySQL client with a newer image of MySQL right on the command line, And it's only going to be running long enough to give us a little prompt, and it's got MySQL client installed on it. That's all this does. This little MySQL client is just a MySQL image of Docker. It's going to pull it down and run it and then drop us into a shell on it. That's all it's going to do. And we're going to very quickly just say, well, can I connect to that? So now we're here. We're going to run a MySQL command to connect to that service by its short name, because we're in the same directory or the same namespace with it. We're going to say the user's root and the password's very secure. And we're going to say, show me all the databases. And those are all the databases that came with this Docker image as we deployed it from scratch. And it says, don't do that. And you're like, well, this box is, we're in an ephemeral container that's going to exist until we leave. And then when we're leaving it, it's never going to exist ever again. So that's probably okay. Anyways, it said, did it show anything? Why or why not? And we can say root very secure. So we can connect now to that. And we're just going to make a simple little new table, new database, right? So we changed to, what database did we change to? Oh yeah, we just went into the default and we created a table for persons with the same values that we had from the other one. We just didn't put any data in there. We'll exit it. We'll reread it again. And now, all kinds of other stuff going on. But here's that one table, which is, what was it, users? What do I call it? Persons. There's persons right there. Right? So we were able to read it. And then it says, look at you learning Kubernetes. You solved this challenge, created a MySQL database pod to use as a 3-tier application backend. That is a portion of that 3-tier app that we built. All we did, though, was load it up with some basic data. We didn't do all the other stuff and then secure it and all that. But I want you guys to kind of see the layers of this and how you kind of peel it back. And then you just need to learn the individual pieces to it, right? A lot of this stuff is exactly what's going on inside of companies. This is why people use Kubernetes. Is it's real quick to stand this stuff up, real quick to test these things and then tear them all down and then give the resources back and then run whatever you want to run in production, right? But there's a million different ways to do this stuff, and all the namespaces can be unique and the way that you run your clusters. I actually read that there was some company that had like thousands of clusters, and it's like, or you can run a few clusters and then break. Like, there's a lot of companies doing this a lot of different ways. Some people, I've actually seen people spin up Kubernetes clusters just to test things and then tear the whole cluster down. If that's what your security policy and what we call your security posture in your organization dictate, do it. Where's the persistent volume stored? What happens if the node on the volume goes Tango uniform? In this case, Robbie, it's since it's just a lab environment, we have a very small little system. It is just maintained locally. So for us, so Robbie asked, whoops, I thought I hadn't. Oh, I'm in the container still, guys. You guys got to stop me sometimes. CD to answers. In this lab, which the lab wasn't linked recently, so I'll link it back over on the YouTube in case anybody got here later. On the Twitch side, I thought I had it pinned, but apparently it went away. Here's the definition of the. So the answer to that question is, in this case, I'm not doing it to some. I don't have like some kind of persistent storage layer, but it could be any other type of storage layer out there. You could have Google backends. If you're using Google, you can use AWS. There's all kinds of places that we can store these. My case, oh gosh, come on, MySQL dash, what is it? Storage. In here, I just have it local on the one host. So yeah, if this is not a that does bring up a good point. I have in this environment, I have only one node. This is a tiny little cluster environment. So if this node goes down, the storage backend also goes down. In some environments where we're running maybe multiple controller front ends and then multiple nodes, we will have attached storage. That storage, a lot of times, if you're on the Red Hat side of things, that'll be like OpenShift used to use Gluster because they own Gluster, but they moved away from that. They really want you using Ceph, which is just a block storage. Block storage, God. Object storage, guys. I don't know what's going on with me. Block storage are things you attach to the side of file systems. It's a it's an object storage, and then you can just have your information out there. Ceph is block or file or object. Oh wow, okay, yeah. I guess you could tune Ceph how you want. I've only ever, I guess, used it as object. I didn't even think about it being block or file as well. But yeah, I think Ceph is kind of multi-purpose. And they picked both of them up, Gluster and Ceph. And I remember when we were setting up OpenShift years ago at AAA, they were, we were testing both. And then they were like, well, you don't really need, and this was like all of our reps would come out. And we had, when I say like we used a lot of Red Hat, like I remember one time we had like 30 guys from Red Hat come out and just like hang out with us and stuff. And we were pretty big on their stuff over there. And we were going to deploy it, and they were like, well, you really don't need to work on Gluster anymore. And we're like, why? You guys own it. And they're like, yeah, we own it. Yeah, go ahead and stick with Ceph. That's what they told us. And we're like, all right. So then, I think it was announced later that they weren't sticking with it. And that was actually interesting. That was pretty early on in the Ceph Gluster part of things, because I remember that Red Hat told us too. They're like, okay, but when you use Ceph, you've got to use this tool called Rook, and Rook was allocating the blocks that would be used as a storage, whatever we want to call them. They're not really blocks; they're, I guess, blocks of space. The persistent volumes, as it were, what the back end to the persistent volumes were, and we were like, okay, wait, so we're going to use Rook and we're going to do all this in our OpenShift deploy, and they're like, yeah, and we're like, okay, and that's part of your Ansible config, so that's supported, and they're like, we don't support Rook, and we're like, but this is GA. GA is like generally available. It's not in beta, and it's not. We weren't testing this for them. This was generally available, and a part of it that was built was not supported. And we're like, that's not going to work for us, guys. We're like, we're going to need that. And this was still when we were like rolling out and stuff. And I'm sure it's supported now. I'm sure we worked something out with them, but yeah, good old Red Hat. That was back. By the way, I'm like Deckard Cain here. I'm like, stay a while and listen. That was before Red Hat was owned by IBM. Now, I know that was only 5 years ago that they got bought, but I'm like Deckard Cain. I'm like, stay a while and listen. Anybody know who Deckard Cain is? I know some in a group of this big, somebody here knows who Deckard Cain is. Well, people that have listened to me probably know who he is anyways, but he's definitely an old guy, and he's definitely good at telling stories. Non-major nerd. You're lurking. All right. I appreciate lurking. Lurking is fair. But we built that out. That was just the back-end storage. That wasn't this other part that we were talking about earlier. We have this other talk on this, and this is what we started with, which was like the 3-tier app. And we built this part out, the ingress controller, the back-end. This lab was just focused on the database piece, right? This was kind of like a precursor to that lab. But I did this lab first because, one, I thought it would be more fun, and two, I just organized these earlier today, so like some of the things were there. Waiting to see if I'm the only one that knows that reference. Oh yeah, Robbie got it. Well, you probably knew it too on the Twitch side, but on the YouTube side, somebody got it. He was the original character. I know you know non-major, but he was the original character that would identify all of your items, and he sat around the campfire in the 95 version and later versions of Diablo, right? And fun fact, let's see. Let's make sure it was 95. When was Diablo released? It was 96. Okay, 96. I got my time wrong, but the game Diablo was it says Blizzard in 97, in fact. Anyways, I just thought it was 95. But he would always say, stay a while and listen. He that game is the first time I ever built a network between two. Me and a friend called each other over a modem and stood up a little network, and we used to play the crap out of the original Diablo. If you're not familiar, man, go play that one. I know there's all the new ones, but some of those. Stream is Ask Deckard, came stream redeem. That's actually pretty nice, non-major. Yeah. But he would identify. So if you were down in the dungeon and you wanted to identify some item you had, it would just have question marks. You couldn't tell what it did. You'd have to use a scroll of identify. But if you went to town, you could sit with Deckard and he would say, stay a while and listen, and you could just identify all your items and then you go sell them or do whatever. But yeah, the original Diablo was. I know I saw a thing today. I was watching the Xbox stream a little bit on Twitch earlier, and they were doing the. Is it 4, but then I thought 4 was already out. I don't know. I don't know all the Diablos besides 1 and 2. Those are the only 2 I played, but I thought 4 was already out, but they were re-releasing it, or are they releasing 4 version 2? I don't know. I don't know what the hell they were doing. I thought it said 4 when I was looking at it. Like I know my Roman numerals, I think. But but I was like, wait, I thought that one was been out for a while. But anyways, all right, I don't know. I don't play a lot of video games. I just watch people get hung up on meat hooks and Dead by Daylight. That's like my thing that got me into watching Twitch. I don't know why that does it for me, but that's a fun little thing for me. So that's a fun thing. All right, so let's do one. Let's switch gears because I reorganized these earlier. We're gonna just keep going backwards, and we're gonna do something that I think is one of the most important things. Like yeah, I'm a systems engineer and I build platform engineering stuff, and I care about metrics, logs, and a little bit about trace. I don't really do a lot of trace, but I do help my dev teams a lot figuring out what is going on with their applications and stuff. And one of the things, if you tell me, Scott, I like tech, I like doing this engineering stuff, but I have no interest in just doing command line Linux all the time, I would say that's fine. It's perfectly fine. Guys, I accept that I'm always going to be like the guy down building the servers and watching boots and kickstarts fail and all that crap. I've already accepted that that's kind of what I'm going to do, but I enjoy that. Like I'm like if you ever heard the old thing about like the same thing with arguing with an engineer and wrestling with a pig in the mud. Have you guys ever heard this? After a few hours, you realize that the pig enjoys it. It's the same thing with an engineer. Like I like doing that stuff, even though I act like I don't. Where I'm going with that is this next part I'm going to show you is stepping up into what people call event-driven engineering or event-driven, and it really is like the standard. Like if you tell me, Scott, I want to do stuff in the cloud, I want to get out of that space, I want to do like this cool cloud engineering stuff, I'm going to tell you absolutely you need to understand event-driven, and Kafka's one of the big parts about it. It's one of the kings of it. Kafka comes from an old Russian author. I say old. He died in his 20s, and he had like 30,000 short stories or something. So Kafka is always ready to write, in case you guys are wondering. Was he German? Is he German? Are you sure? I thought he was Russian. I'll take your word for that, but I was pretty sure he was Russian. He's German? Somebody help me out here. Cheeto, I'm going to need somebody to do an objection. Hold on. Is there an objection? Born in modern day Czech, but spoken, wrote in German. Okay. All right. Fair enough. And I don't know enough about that part of the world to argue, so that's probably right. But we do agree that he died pretty young, and he wrote a whole bunch of stories. So Kafka's always ready to write. That's what the name means. That's why they picked that name. But before we talk about it, I'm going to take you to serverless land, which I think is one of the best things I could show you. If you don't work in this space and you say, "Hey Scott, I want to get into this space," this is probably one of the best things I could show you. The actual use of info. Yeah. So serverless land is like it's event driven, but again, I don't like using like terminology that's just like the buzzword of the day. I try to use things that are accurate and correct. And event-driven programming is actually exactly what it means. It means an event happens and it triggers somewhere, and then it goes and it waits in a queue, SQS, SNS, whatever type of things. SNS isn't strictly speaking a queue, but SQS is a queue, right? And it sits there, or Amazon Event Bridge is another way of doing what I'm going to show you with Kafka, where we just throw things in there. And then it's almost like a little, it's like a train that goes around town, or if you want to think of it as a subway, if you're from a place that has subways, and the events just sit there. They just ride around, and anybody can query those events and pull them out in the order. There's replayability, so I can replay the last day of events that have gone in there. And where I got into Kafka, when I use Kafka, like some of you will be like, oh, I use Kafka and I wrote into it from an application and then I pulled it out over here, and I'd say, that's awesome. That's what some people use it for. I was working on the NOAA project back in 2000, and the Shasta was created by Cray. Cray got bought by HPE, so Cray doesn't exist anymore. And their HPCM tool, HPCM still exists, but the Cray Shasta tool no longer exists. It was their big high performance compute like flagship, and it was awesome. It was all Kubernetes for our systems and connections. But anyways, the logging that we did was unique. I had never seen anything like it before. We took all of the logs and everything on the server and all the events, and we just tossed them into a Kafka bus. This is part of the Shasta design. And then this little Kafka bus just rode around like this. And then over here, there was it was some kind of Kafka consumer. I think we used either an Elasticsearch, like a plugin, or I know Telegraph will do this. A lot of times we'll use Telegraph for it. I don't remember what Shasta used, so I can't tell you that part of the architecture. But what I can tell you is we pulled it out of Kafka into Elasticsearch and then used Kibana to graph and visualize all of our data. Now, in my lab, I have something that's very similar to that architecture. But I'm saying all that to tell you guys that I got into it from the monitoring side of things in high-performance compute. I've got these big systems, just big servers everywhere. We had 2,665 nodes in each cluster. Yeah, 2665. And they were in both clusters and in two different locations, and they would write to their own buses, and I could see everything that happened in the cluster. I loved it. It informed my design for how I do all my home monitoring here. So all of like my home lab monitoring stuff, which is Telegraph to Influx to DB and then to Grafana, or Node Exporter to Prometheus to Grafana, all this stuff here was all informed from what I learned in that Shasta cluster. But I bring all that up to say, if you want to learn event-driven stuff and you want to do it in the cloud, serverless land, which I just linked a little while ago, is one of the best things that I think you could spend time in. Because there's another reason to do serverless, the concepts of serverless, is you could probably spend, a few hours a day deploying things and tearing things down around Amazon Event Bridge, for sure step functions and Lambda executions and stuff. And you could probably spend 4 hours a day for like a month just practicing this stuff, and I don't think it would charge you $10 in Amazon. The serverless component of Amazon is as close to free to practice with and play with as anything. It's almost, you are probably spending more by watching this instead of doing something else than if you were just going and playing in there, as far as like an opportunity cost. Like, you could go be doing almost anything else, right? So my point in saying that, I worked on something that was file beat to Elasticsearch to Kibana. Yeah. That's there's different methods for getting stuff in there, and elk stacks used to be huge back in the day. But anyway, serverless workflow, they show you how this stuff works, and then you can go build it for yourself. And then you can just have a simple little thing. A couple other things in here. One of the reasons I like this as well was when I was getting my AWS Developer Associate, which between that and the CKAD, I have 2 developer certs, even though I'm not a developer. I don't, strictly speaking, write code, but I understand it, right? I don't write code professionally anyways, let's say that. You got banned from AWS Inspector. Yeah, well, that's not surprising, Inspector. You get banned from a lot of stuff. Real quick, let me show you guys this. Patterns. And then let's say that you're wanting to deploy something in the cloud, and maybe Pulumi. Pulumi is an awesome tool for you guys that come from the coding side that want to get into deploying your stuff out there. So is the SAM framework. That's the serverless. What the hell's that SAM stand for? Anyways, they'll tell you all about it here. Serverless Application Manager, isn't it? But that is a framework that goes right into your stuff as well. Where I'm going though, let's say you're a Terraform junkie and you love Terraform. This will show you how to deploy stuff with Terraform. Look, I want to do an application load balancer to 2 different Lambda, and that's how I want to like hit things. I can clone this down and go look at it. I can come in here and actually look at the different pieces and go, okay, this is interesting. I have to feed it in a region, right, as a variable. These are variables inside of Terraform. It doesn't work directly out of the box. You got to think a little bit, guys. But it's enough that I go, yeah, okay. So I got a public subnet 1 and public subnet 2, and those are going to be out there, which I need for the load balancer to get there, right? And then here's my route table. I could use public route, or I can name that something else. And then whatever my connections are, and then I can build there's my route table associations, my internet gateway. By the way, some of you probably know this, but here's a little piece of trivia. If anybody ever asks you the difference between a public and a private subnet inside of AWS, the only difference has nothing to do with the names. Names are cute, but they don't matter. They're literally a tag they're a key value pair assigned to the resource, they don't matter, is whether or not the route table that is associated with it, because there's one route table associated with a subnet, whether or not it has access to a gateway. If it does not have a route to a gateway, it's not a public subnet anymore. And you can change those. You can name things private and put them in public and confuse the shit out of people if you want. But that's neither here nor there. I'm showing you guys this because if what I show you here clicks and you're like, oh, that's slick, you can go run it up here. And if you're like, man, I don't want to use their event bridge. Remember I said event bridge is their kind of way of doing it? Maybe you say, no, Scott, event bridge, which you said is like Kafka. They're very similar. They're the same concept of like the little trolley going around town or whatever. I think of it as like somebody just sitting on a subway, right? Just sitting there. Did it break? Okay, no, it didn't break. Okay. If you don't want to do event bridge, they actually have MSK, which is Managed Services for Kafka. So you can find MSK inside of serverless land as well. So if you're like, Scott, I don't want to do their stuff, or maybe we already have a lot of engineering hours and a lot of code in Kafka, you can use Managed Services for Kafka in the cloud as well. And there's reasons to use it. There's reasons to use that instead of Kinesis data. So Kinesis has different ways that you can write data into the cloud. And maybe you want to use Managed Services for Kafka instead of that for capturing data. Because Kafka is really good. What I'm about to show you when we do this lab is really, really good for if you want to do Internet of Things as well. So in my case, I had 1,200 nodes, or sorry, 2,600 nodes, throwing data into Kafka bus and then just collecting it on the far side. It's like a guy sitting there like pulling sewage out of the canal. It's super easy to get that stuff out. All right, so anyways, let's look at it. Enough talking, right? Like what's anybody here ever seen Conan the Destroyer? I think Conan the Destroyer is the better of the two old Conan movies. But in Conan the Destroyer, the guy's like, give us the girl or we'll take him, or we'll take her. And Conan looks at him and goes, enough talking. He just throws the knife and kills him. And you're like, well, it's time to fight. Conan's all done talking, right? And where I'm going with that is enough of that. Let's actually build this. So all those things I said, let's actually play with this and get it to work. Let's hold it in our hands and understand. It wasn't just, he was in the newer one, but I want my Conan to have so much muscles in his neck that like when he says the word crom, it sounds like he's like birthing it out of his like muscular, right? And Jason Momoa wasn't that big back then. He might be a little bigger now, but he wasn't that big in that one. So I want him to be more Conan size. Not mini Conan. Anyways, all right. Welcome to ProLUG Kafka deployment into Kubernetes. So your team has decided to invest this concept of event-driven architectures. That you guys have heard the things. Everybody's talking about it around the water cool. You know, different engineering teams are doing it. And you don't want to be left behind, right? So event-driven architecture. Also, again, this lab is free up in Killer Coda. But if this doesn't do it for you, go hit that serverless LAN link and go play for literally, guys, I'm telling you, it would be pennies per day in the cloud to go build that stuff and tear it down and build it and tear it down and build your little Terraform and deploy it. Pennies per day. Again, you would probably spend more on like a Udemy course than all of the time that you would spend building that stuff out. So it's very valuable to you. How many shitcoins was he able to mine? Smur, we have at least 2 people inside of our Discord that have had that same exact thing happen to them. Well, he mentioned over on the Twitch side, somebody spun up the largest EC2 and then left it up and got a huge bill. 2 guys in our Discord have had that happen to them that have admitted to it. And one of them actually works for Amazon now in the AWS space as a solutions architect. So there's that. But like that, he also got it, removed. If you guys ever wanted to know, by the way, like if you're like, hey, is Amazon really like cheaper and better at some things? I worked for a company years ago, Caris Life Sciences, and let me tell you something that if you know nothing about systems engineering, I'm going to tell you that what I'm about to tell you was a resounding success. But then I'm going to back up and say, if you do know something about systems engineering, like if Robbie's around and He knows systems engineering. He's been doing it a long time. He's going to listen to this and go, damn, that was a resounding success around AWS. But to that point of like spinning up the biggest AWS cluster you ever did, let me tell you about what we did at Keras. We had 4 million records that we needed to turn into, and this would have been like 2015. So there were services that would do this for us, but we wanted to do it ourselves. We were internal. We wanted to control some things, and there's compliance laws and all these other things. And I'm not going to mention all of them, but we wanted to see if we could take one of our old servers. We were going to take one of our old servers that was just sitting there, and we were going to just process through 4 million PDFs that we had and do basically like a Tesseract OCR. That's exactly what we ended up doing, by the way. But does everybody here know what Tesseract is? Have you guys run Tesseract or played with it? If you've never played with Tesseract, there's a bunch of them, but this is some guys. And Tesseract will look at a picture and it will turn it into the text. Like it could take this, if this was just an image, and it would figure out most of these letters and words. Yeah, it's from the Tesseract. Yeah. What Tesseract is, if I took this as a picture and then I sent it to you and you tried to like copy it, you would not be able to copy this. You guys know that, right? Like most of you are like, oh, Scott's an idiot. He's explaining to us an idiot thing. But hold on. What if you had images of like doctors' handwriting and prescriptions and things that had been, or maybe even stuff that had been medically, I don't know, whatever. The point is we had millions of records, 4 million in fact. And some companies, I worked at AAA, they've been around since 1906. We had document competitions sometimes for fun, and we would have documents coming in from the 1930s that people still had in their offices. Where I'm going with that is you want to get all this up into your data stream, right? So we were going to take one of my old servers and we were going to process, scan old books, We were going to take all these PDFs that we had that were not, we had some information on, but we were going to take them all, we were going to strip them up, we were going to meta tag them, be able to find all kinds of things, and it was going to be wonderful, right? And we were going to take one of my old servers and do it, but we had determined that the processing power we were going to need was probably going to take us a few months on that server. And we said, could we do it a little better? And again, this was like 2015, so like my biggest server in the data center probably had like, back then, probably like 128, maybe 256, like on my little boxes. I have way bigger boxes now, but back then, 128 or maybe 256 with like maybe 32 cores was probably the most dense thing I had. And we said, wait a minute, hold on. We could get this big old honking thing out in AWS, and we can spin up, and we basically did what you described earlier. We spun up the biggest AWS instance we could. We got everything ready. We ran it through and some tests on some smaller boxes, and then we spun up the biggest AWS instance we could build at the time. This was, again, 2015. And then we ran everything against it. It took 24 hours. It took one day. It cost us $960 of Amazon EC2 time. And some of you are probably in your head going, $960? Well, for a month, that would have been $30,000. Oh, that's expensive for a server. Sure. But hold on. What if we had wanted to buy that server? That server would have cost us at the time tens of thousands of dollars. We would have waited 3 weeks to get it. You would have had me racking, stacking, putting an IP address on it, setting up an operating system. I can do that stuff as fast as I want. That's still going to add at least a day, but maybe like 2 or 3, depending on if I hit any other hiccups. Then we got to stage all our data, right? Which I guess you still do that in the cloud, but that's neither here nor there. The point is, we did it for $960 on a weekend, and then we turned it off, so it didn't charge us any extra money, right? But the point is, it was a resounding success. Saved tens of thousands of dollars and months of time, right? Like just if you think about how you can compress that, that was really good. So other things about that were interesting. The director of engineering for that software team, because I was the Linux guy and the high performance compute guy. The director of that team for the software engineers, he was over about 12 guys. We weren't a very big company, and he loved PHP. He was a PHP guy through and through. So I looked at some of his code, how he did it, because he wrote all the stuff that ran them all through and did all the OCR stuff, and it was all PHP. And you go, not on a web page? Nope. It was all PHP. That guy, he had a full PHP shop there, and I had mentioned that before on stream, and some people probably were like, no, nobody's running PHP as they were running PHP as real code in our environment, and it worked just fine for what it needed to do. I'm sure there's all kinds of reasons not to, guys. I'm not a coder. I don't do that kind of stuff, but I can tell you that it was really funny, and I always just think back to it because the guy never missed, man. He was really good with PHP, and all of our stuff worked really well, but we were a PHP shop. Which was funny because all of our data science guys were Python guys. So, but it all worked together. How did we verify the process went well? We got a lot of, we had tested on smaller batches on smaller jobs, which, by the way, was also cool because then we could spin up really small test clusters. We had the metadata that we needed. We had things grouped the way that we expected them to be, and then we just kind of moved everything off, and it was good. And we had our backup in the cloud then, too, as well. Can confirm also Python. Yeah, non-major nerd, there's a lot of Python in our Discord. The bot that basically plagues me every day inside of our Discord is made completely in Python by one of our guys. Yeah, and I'm not advocating for any one thing. I'm just going to say, for all the bad stuff I've always heard about PHP over the years, like people like, oh man, nobody should code in it. I had a director of engineering, and again, I wasn't that guy. I was the Linux guy and the HPC guy. And that team was well run, and almost everything they produced out of there was completely PHP. They did some other stuff, but like all of our internal stuff, when I would get scripts from them and deploy stuff and all that kind of stuff, was always PHP. I was always like, huh? I mean, look, man, like if you're really good at making a bowl of spaghetti, I don't know, man. Like, well, who am I to tell you can't make spaghetti? If you're like the soup Nazi, is that word gonna come up? That didn't come up. But anyways, if you guys remember the old Seinfeld show, the one guy who he sold the soup, and he was a jerk, so he would just kick people out. But he was always selling soup, so I guess he did one thing well. Anyways, let's look at this. So we're going to deploy, for Kubernetes to run Kafka. Well, for Kafka to run an environment in general, you need Zookeeper. I think the newer versions have been decoupled from this, but back when I did this lab, and when I first started using Kafka, you needed Zookeeper. So in our deployment, we're still going to use it. So we're going to create a namespace for Kafka. Strictly speaking, you don't need it in its own namespace, but you can. We're going to create a node port for the Zookeeper service with node port 3090 so that we can just connect to it. We could have also done a cluster IP. That's fine. And then create a deployment for Zookeeper that uses the default Zookeeper port of 2181. Here's our tips if you want to go read about Zookeeper. And here's our solution, which is create the namespace. Check that there's nothing in there, but the namespace exists. Good. Here's our Zookeeper file. Here's a basic service up here. And here's our basic deployment that's just going to go and grab the Zookeeper most recent image. We're not even getting a specific version. We're just going to get the newest one, right? We'll create it. We'll go look at it, and we'll see all those resources there and coming up. And it says right here, wait and run that command a few times to make sure that the service should eventually have the endpoint of that pod on the right port. So we'll give it a few seconds to come up, and there it is. 192.168.1.4. I don't even need to go look at that pod, but when I do, I know that pod will be the right backend. 192.168.1.4 was selected by this label. The app Zookeeper is one of its labels, and then, well, it's the one that it's looking for, and it's going to have that endpoint IP address. There we go. Boom. And if I do, watch, show labels, I am 100% positive that in there, one of the labels, at least one of the labels of this pod that we have, will be this right here. App equals Zookeeper, because that's the selector that points to it, so it has to be there. There it is. Oh, a dev I work with was able to take a project compilation from about an hour to less than a minute by spinning up a huge EC2 build machine. Costs like a few dollars to build, but dev salary for an hour of sitting waiting versus build instance. Smur, I'm 100%. I'm sure I'm sure that's the case. I bet it saved them quite a bit of time. By the way, for people that are interested in this stuff, I will eventually be turning back towards doing more of my AWS stuff, and I probably will, since I have the developer associate, eventually go for like the DevOps, which is the other professional cert. I have the Solutions Architect Pro, but I'll eventually go for the DevOps Pro. When I'm doing that on stream here, I will show you guys how to build pipelines, and because I know all the different pieces and how the code build will build our code or whatever, but it's very similar to that. It spins up an EC2 batch instance in the background, builds your code and builds a code artifact that goes and waits for your deployments and stuff. So it's all stuff and guys, this stuff is very, very cheap, very possible. All right, I got a question over here for what do I think of DevOps versus Agile Scrum? I have a talk on soft engineering skills. Let me pull this up real quick. In my ProLUG presentations, I have like just soft engineering skills that I think like are good for an engineer to know or think about. Again, I tell you guys all the time, I don't care if you know who I am. I am a real person. You could find me on LinkedIn, all that stuff. I've been an engineer a long time. Don't care, right? But down here, I got stuff to add. But this is like my thoughts on Agile is something, actually, this came up, I think, yesterday when Robbie came and talked to our group on Saturday, and he came and talked to the Linux engineers. And one of the things is people are like, all right, we're going to be Agile. And they like clap their hands and they're like, we're going to be Agile. And then they talk for an hour in the stand-ups and people are doing bike shedding and they're doing all this other stuff that just is just like, oh my God, this is the worst. Like I'm an individual contributor. I'm an engineer. I need to be engineering. I don't need to be sitting in meetings, right? But to the point of if I like Agile or Scrum, my favorite methodology I've ever worked under, as I say this, I'm going to give the caveat. I am not a code engineer. I don't, my artifacts for work are not blocks of code. They are not code reviews. I do get pulled into code reviews, though. Don't get me wrong. Like I've been an engineer long enough that people know that I can figure stuff out. So I get called into code reviews for our Git and that kind of stuff. But where I'm going with that is, I do not produce artifacts of working code. That's not what I do as an engineer. I produce working servers. That's my output. Scott's output is baselined, hardened working servers that are deployable like that with Ansible over and over again in an environment. That's what's successful for Scott. So where I'm going with that is my favorite way of ever being like managed by people has been Kanban. I love Kanban, but maybe that's because I've seen it work well. Kanban, if you guys don't know, is just basically you could do it you could have a little whiteboard side to next to you, or you can have a whiteboard up on the thing and you take post notes and you move them between to do, working, done, deployed, I mean, you could have like 100 of them, but I love that. I really like Kanban. It's really easy for me to see. But Agile has also been really well done when we focus on this stuff. So me and Robbie were talking about this yesterday, and then this has worked well for me as like an engineer, where like just me and one other person who are like the guys who you want to be somebody who gets stuff done. I tell people all the time, if I sit in a room full of 100 engineers, do you know how smart I am compared to all those other engineers? It doesn't effing matter. It doesn't matter. I tell people all the time, I'm not, I 100% for sure know if Robbie's around, I'm not the smartest engineer in the room. But what I do know for certain is I'm going to be over there building stuff that works. And where I'm going with that is I like to grab somebody else that's also like that and good at getting stuff done. And he and I will go work together. And that's this idea here of individuals and interactions over processes and tool, and working software, like quick iterations of working things over big blown out comprehensive documentation. This is your proof of concept and your minimum viable project or product, those kind of things. Customer collaboration, working with the other teams instead of arguing over your service level agreements. Guys, we're going to miss the service level of agreement of turning this shit on at the end of the month if we don't get it built, right? So anyways, get done with a task, grab another, don't sweat the sprint plan. I agree. And here's the thing. If my sprint is going a little slower because I'm helping another guy drive his so that my piece connects to it, that's still better, right? And I'm, again, in a room of 100 engineers, I do not plan to be the smartest. In fact, I'm promising you I'm not. But I guarantee you I'm one of the top 3 in like getting stuff built. Because I just know that, and you can call that hubris, you can call that being a Chad, you can call that whatever you want. I've been doing this long enough to know that I'm good at building things. And I don't have to be the smartest guy in the room. I let that go a long time ago, right? And you know, there's always a little bit of hubris as an engineer, like, oh, I want to be smart. But, you know, I tell you guys, I've known 2 guys in my career that can do calculus in their head. And you say, like, I can give them a number and they can have a calculus equation, they can tell, yes. Yeah, I know guys that can do that in their head. Most of us can't. So then when you've worked with guys like that, you're like, well, I just hope I'm good at something. I'm good at building stuff. Yeah, Giga Chad. Yeah. Anyways, we'll do that talk one of these days. But let's keep building this. So we built Zookeeper. We've got it all up. Said the above commands only work because you've got everything to work. So boom, validation successful. So now that you have a namespace for Kafka and Zookeeper running, we can deploy Kafka in our environment. We normally wouldn't use a node port for this, but we're just testing in the lab. That's fine. Want to be smart enough to get a high-paying job and keep it. Feels bad. Yeah, Apollo, look, I have been... Do you know that this is a question that like I've had managers ask me over time? Did you know that you can do everything right and still just not be right for the company? Or you could do everything right and a project that you work on could still fail? And that's a question one of my managers like to ask people. What's a time that you worked on a project and you did everything you thought was right and it still failed? A lot of people tell me their college stuff, right? Because like people hate working on projects in college because people are terrible and don't get their parts of it done. Where I'm going with that, though, is I worked for Best Western. I left AAA right at the end of 2019. I told my boss, hey, I liked working for you. I'm going to go try this thing. I'm going to go be their Ansible architect. I'm going to come on for 6 months as a contractor. So I was a contractor with Best Western when COVID hit. I was doing everything right. I had built their AWX out. Some of the guys in the Discord worked with me there professionally at the time. I had all that stuff. I took over patching with Ansible, and I trained the guy who is now running all that stuff, and he's really good. But anyways, they let go 680 contractors, and I happened to be one of them. I was doing everything right. The manager had pulled me aside before COVID hit, so this would have been like February, March. It would have been like February. Yeah, he was like, hey, Scott, we love you. We're going to hire you. Just keep doing what you're doing. The contract will convert. But they had to let everybody go. And then like, but I don't sit around and go, oh man, I wish Best Western loved me more. Right? Like it sucks to not have work. Don't get me wrong. But what I'm saying is like, that doesn't affect my ability to do things, if that makes sense. So like, yeah, I got let go. I was actually, but it wasn't even like a layoff because I was just a contractor. It was just the contract ended. They had to save money because literally nobody was staying in hotels. So. And then the joke was when I told my boss that I was going to go work for Best Western, he went like this. He said, Best Western? Best Western? I'd sleep in my truck before I slept in a Best Western. So that was, yeah, better to sleep in your truck than a Best Western. So yeah, Robodom got it. All right, anyway, so let's keep building this out. Solution, we'll go look at our answers for Kafka. Now, this is the same idea that I talked about earlier. We've got a service. And we've got Kafka, but we need to give it some of these values. And we can give hard environment values here, or we can pass them as configuration maps or secrets. Typically in an environment, we'll put these in as secrets so nobody else can read them. So even if you get a hold of my little block of deployment here, or you compromise my Git where these are all stored, these would just be references to those links or to those secrets or config maps, and they wouldn't mean anything to you, and that's fine, right? You can't build a system that has a sigil hard-coded iteration. Manager went with Agile Bro, and then later wanted more sites validated. We had to explain that it'll be 45 times the cost to one-off for each. Yeah. Oh, you can't Agile code hard-code iteration. Fair enough. Yeah, and I will use. I've told you this before. This is one of the things that, like, I think early on in the career, people get like really like I even get people coming on here and going, this guy doesn't do any Linux, he's in Windows. And I'm like, you sat here for more than 5 minutes and didn't see me do any Linux? I scoff at that. I was definitely doing Linux the whole time. You just the tool I used to get to the Linux. That's like saying that like you think that because I drive a Ford, I drive a Chevy by the way, but maybe this is true. I was going to say, just because you think that I drive a Ford to work, that I'm not going to be able to engineer when I get to work. You'd be like, oh, that guy drives a Prius. He's obviously an idiot. What the hell? What are you talking about? It's the same idea. As long as I can get to a command shell, I can do anything. I let that stuff go really early on in my career as well. And it was something actually, if Robbie's still around, Robbie actually used to have this outside of his cubicle at work. And when you walked up to his cubicle, you'd see it. And it was this thing, it was by his name, and it said, this is going to be something to the effect of it, but you can go look it up. It said a programmer can code in any language, and then it said like A, B, C, C sharp, all the way down. It had all these languages, and then at the end it said specialization is for insects, and I thought that was great. Like I'm like that's actually brilliant. I don't care what tool I need to get to what it is. That being said, I love Ansible, but all right, so let's deploy this, see if it builds. We'll go look at it and see that now those things are coming up. And we'll go look at our services, and it doesn't have a backend yet, and the container's still creating. So let's see. Container's still creating. And that guy, by the way, is a coder, so he does do that professionally, whereas I do not. All right, so we've got our backend, right? App Kafka broker is the selector, and that points to this, which happens to be 192.168.1.5, and that's Kafka broker. All right, good. So we got a Kafka broker up. We hit check. And now, if we've got Kafka running in our environment, it's got Zookeeper Kafka, we should be able to send messages in through producers and read them out through consumers from the broker, and it should be good. Yeah, HashiCorp Vault's pretty good too. Yeah, core count. I used to build labs out here that were on HashiCorp, and I used to use HashiCorp Vault quite a bit in my home lab. I have a Vault that's up now, but I don't have them configured right now to do a lot of the stuff that I'm eventually going to do. So I may stay with Vault. I've got a slight bit of a problem with the whole IBM thing, but I had more of a problem with the business source licensing last year. So I don't know. They're fine, I guess. But all right. So there's some documentation about a tool called Kafka Cat. This is a tool that will allow you at the command line to send data in and read data out, which is what we want to do. We want to send data in and read data out of the system. And also, I don't know if I have it in this lab. I might have written it into this lab. Let's go check. If I wrote this in, I did not write this in. I had a Python read and write. We can go find one and just use a generic one. But let's see if, and then we're going to set up our port forwarder to send to it. And then we're just going to make sure that that's all working. And then we're going to send with Kafka Cat some messages at a certain time into our node 01 on port 3100 with just test in there. So we'll just hit that a few times. And it looks like it handled the connection. We'll go ahead and just do it a few more times, right, just for fun. Like disable KV store and do public key crypto. Nice. All right, so we've got a few writes. And then let's see if we can consume. So we were producing. Now we're going to consume from that. And there we go. We read them. And now we've got the end of the topic with an offset here. And that offset can be used to then pick up and read from the last message you've read. So if I go read it again, it'll say reach the end of topic at whatever offset. And then I can go write some more in there. Whoops. Write some more in there. And then I'll go read it again, right? And it'll say reach the end of the topic at offset 7. So you can actually then take that and you could store that, like people will store that. I've seen that stored in Redis before. So Redis is like a caching tool. It's an in-memory cache, typically key value store. I guess you could use etcd for that because etcd does that as well. You could probably put this in a lot of places, but what I've seen this done is whenever I read to wherever I need to, I go and I set the offset somewhere. And then all my other nodes, they'll go read what the last offset was, do their read, and then they'll start at that offset and continue reading, or maybe pull 3 blocks of whatever. Guys, you can put events in here. You can have this be, again, for me, it was events coming off of servers as messages, and errors and all kinds of things would go in there. And this thing can get pretty chatty, but it's always ready to write. But anyways, the point is we could read up to like event 7. Next node comes in, reads it out of the data store. Boom, reads the next ones, puts the new one in there as the new offset in Redis, and then you just have your devices. And there's probably some tuning in there for maybe some race stuff where 2 nodes would read the same thing, but there's probably a fair amount of like ways to deconflict that if you wanted to. And I'm sure inside of maybe you have a read that says if this, we don't read that if it's been written in the last 3 seconds or something. I'm sure there's some Redis for that or something, but the point, and maybe even tighter than that, but the point is you could do all kinds of things with this. I claim no expertise in how you would use this on the software side. I just know that I could stand it up, and now we've got a minimum viable product for somebody that wanted to come along and connect to it. So if you did this with me, you've got 35 more minutes in the lab. You can come up here and say Python Kafka connection, right? And you probably find somebody's blog or Confluent with Kafka. Sure, I'll take your cookies. And that's not as useful as maybe a blog, but somebody, here's Python client, and it says, oh, motherfucker. Like, okay, I'll take your fucking cookies, Jesus. Pip install Confluent, right? Boom. Oh, I didn't mean to do that. grab that again. Control-Shift-V. Get Confluence in here. And then, can I call that? Can I write to that? Right here, here's a basic little thing. But before we do that, websites these days, yeah. It said from Confluent Kafka. So what I do, and again, guys, I tell you all the time, I'm a systems guy, so I have to set these things up for people. You know, if it's production and I'm putting the code in there. So what I'll do is I'll do like Python here and drop into an interactive shell, and then I'll say import that. And if that import comes back without an error, then I tell my guys, I'm like, yeah, that's there. So for me, right, I can get out of there. Those are like the two things I know how to do in the Python command line. But anyways, then now I'm here, and where am I at? I'm in root, right? So I just vi, Kafka write .py, right? Let's go grab this thing. Let's see how good it is right out of the box. Here's the producer. Said you can initialize the producer as shown. And let's see if... So this will initialize it. And then we can do a key value production here. So we got to add all this. Again, guys, I just know how to copy and paste shit, right? So that'll open it. But you might notice none of this stuff's right. I got to go fix that. But then we come down here and we go, okay, synchronous writes are going to wait with it open. Asynchronous writes are just going to write and leave, right? That's the difference between synchronous. Synchronous waits for a call to finish. Asynchronous just yeets stuff over, as the youngins say, right? Let's see if I can, so I got this, producer key, value, whatever. If I had a key and a value, if I was smart enough to do those things, I would. But I'm just going to say Scott test, right? I don't care, right? I just want it to be different. And then the host is something completely different. This is node 01. And then the port for me is 31,000. I do not have more than one server. Oops. I'll hit X. What the F? I only have the one server to use. Which is fine because then I've got the service backend and I can have multiple pods if I wanted. But this should... We'll say what is it? Somebody help me out here. It's user bin Python, right? Which Python? User bin Python, right? So okay, so then we do a chmod 755 on Kafka write, and then we just run it. And it says, oh, name topic not specified. Oh, topic can just be, I believe in this was test. Is that right? Name test is not defined. What were we using out here? -t test. Yeah, I thought we just used Kafka write producer. Somebody help me out here. Where's my producer conf? Go to one client, get sock. String? Oh, you're saying use it like test equals test or something? I don't know. Yeah. So like, anyways, again, guys, I tell you all the time, I'm not a programmer, but I should be able to go and figure this out if I had enough time in the lab to. Oh, look, and then you could fail error messages and that kind of stuff. Synchronous write would do that. Asynchronous write. We'll just write, although the produce method, we can also pull. Topic equals test. Yeah, let's try that. Test as identifier. Like that. Anywhere we want, right? Name test is not defined. Is it just... It's just that that's... Can that just be a string? That's better. And the last line say, oh, I see what you're saying. Hold on. Give me 1 second real quick. Let's go read real quick. We'll use Kafka cat to read real quick. Where's my damn read at? Timeout, read. My mess. Okay, so it didn't do that. You should at the end just do topic. And we just change that back to test. I see what you're saying, because we're doing... yeah, I'm not a Python dev either, guys, for sure. There's our read. Our read's fine. Where's my write? Error name test not defined. Let's go see. There's probably something I'm missing here. Oh, hold on. Initialize the producer, producer.conf, and then asynchronous write to producer, which may be none, optionally. Producer.produce topic key. Kafka consumer, so we can read from it, but I want to write to it still. So it's not this producer.flush, is it? I don't think that would need to be there. Maybe. Maybe, you never know. Right, so this is how we go figure stuff out. Paste in. Maybe. Whoops. Name test is not defined. That doesn't make any sense to me. I thought this was the topic. Control byte. Yeah, we're just messing around. We're trying to get some Kafka stuff to work, and I feel like I just don't know. I don't know enough of this stuff, but handling connection. So let's go read it. That was maybe it. And there was our test. Okay, but why is that? Oh, that's weird. So what did I do wrong here? So test was key value. So we got this part to go in, but why did... That's weird. Because this doesn't work. What the hell is their definition there? Produce test key Scott value. I don't care. If it'll just take a string there, I'll just give it a string. I don't care. Let's see. Let's just try it with a string. Oh, you know what? Hold on. We're gonna do it like that, just so it doesn't try to do any weird Python shit. That did not work. That's weird. Let's go grab that line again. So the only thing that has worked there was this being a string. That's the only thing that's worked there, is this being a string. And then that was the only thing that came out. I don't know. Again, I don't write that much of this stuff, or I don't do any of this stuff, but I can at least get that to go. Hold on a second. Is that writing? That writing somewhere else. Speaking of Kafka, kraft is a tool. It's Kafka without Zookeeper. Pretty useful in some scenarios. Nice. I haven't messed with that at all. I wonder if I'm just being dumb here and thinking that when we read from the topic, maybe it's a different topic. I wonder if there's a query for all the. I don't know enough about it, but I just know to set this up and then send stuff at it. You're trying to use a variable called test that doesn't exist. Yeah, that's fair enough. But I don't know. When it was here, it was a variable test, but even when I had it exist, it didn't work. So when I had test equals some test dot example, I don't know, right? Example, something like that. Even then, maybe. Super weird. It came out only the time that I had that. Literally the only time it came out right. And then now it's not coming out at all anymore. I must have lost my damn mind. Dash T test the topic test. I don't know. Anyways, guys, this is one of the reasons I'm not a coder is because I'd be sitting here all day trying to figure this out. Dash T? Dash T on the test? I don't know. Somebody help me out. Where are you guys talking? Somebody's saying something about the topic name is some test.example. Oh, I see. Hold on. Okay. So that dropped the word value in there, which is over here. Oh, Jesus. All right, now I'm even more confused. Yeah, instead test it should work. Yeah, I got it. So that worked. So this right here, this can be test again, right? And then now I could just do, let's say Scott topic. Doesn't matter. And then key, and then value could be, I don't know, whatever. And then, oh God, topic. Right? Now if I write this, should work, I think. And then now this will be Scott topic. And then it should read. And then again, it's only dropping value in there, but that's still. That at least shows me like and again guys, I tell you guys all the time, it's chutes and ladders. I didn't know anything about this a few seconds ago, but now I know that the topic's being generated here and being put here, right? The test variable's coming through here. I still don't know how to read the key, but I know that the value is getting dropped in as value when I go and I look at that specific topic. So now, at least with that, I can start passing data in. This is one of these things, I got a buddy, Jared, that does data analytics and stuff, and he pulls data out of Google stuff a lot with Google Analytics, and he always tells people he's just a JavaScript copy and paste expert, and he's like, what you're paying for is the knowing what to copy and paste. That's what he says that you're paying him for, is to know what to grab. But in this case, it's like I still don't know everything, but I at least know how all this maps now, except for I'm not sure exactly how this key's working in it, because I've never used key value pairs. I've just thrown data in there, but and mainly for me, I was just grabbing the data that was being thrown in there. But my point in showing you guys all this is there's, like, now you have a minimum viable product of a tool that all of your teams can throw stuff into. It's the same thing with when we did our Loki, and I show you how you can use Python. So like my home lab here, when we're looking at, oh, there's Ranger. When we look at this, and you're seeing all of my logging being thrown into here from all of my different servers, and these are all of the attempted logins into my servers that have been, getting themselves kicked out forever. Well, all of your stuff can just write to Loki, and then you can just pull it out of Loki as you want to. Look, somebody just tried to log in at this very second. This last 10 seconds, somebody just tried to log in as the user EN. Root can't log into my environment, so it doesn't matter. And then all these other users that have been tried to come in. Jenkins, we were talking about Jenkins yesterday. So, root a bunch of root user attempts. Can't get in on root in my environment. All these other ones. Anyway, they're always trying to come in, right? They're always trying to get at the tasty data. Most all of them just want to mine Bitcoin as well, or mine whatever the coin is of the day. So, all right. So we did. How long have I been on? I've been on only 2 hours and 40 minutes. Not too long, but I'll probably hop off of here, spend a little more time with the wife. She was gone most of the weekend, and we just hung out today. She got home a little earlier than we expected, so we'll hang out. So you've put some examples. Okay, good. Yeah, no, Robbie, you helped out a lot there because that was useful for me. I'm going to actually grab some of that. So, guys, if you ever do these labs, one of the things I need to do is I'm going to grab this, and I'm going to go throw it in my notes, right, because I'm always throwing stuff in my notes. And I'm going to add this to the lab as when you're done, run this part, and then in the answer section, there's more to it. There's more to this lab that you can do. Because I have... in some of the other labs, hold on, let me pull up. I'll show you guys in some of the other labs. If you do the Loki lab, and you're like, okay, we've done the Linux install and we've set up logging. Then there's in here, there's some Loki writes where you can then go in and you can just throw data as though it were an application. This is super simple stuff again that I just went and figured out, where you can throw data into this and then you can look at it. And then instead of, I always tell people, like, instead of just writing to a log file on the server, that's cool. But what if I'm deploying to 30 machines? And I don't want to go check on each of those machines to see if they finished. So they can all just log back to Loki, and then you could just have it, you could be like this. Where's my little thing at here? You could just be here watching all your servers check in that they're done. Or you can see all your server failures on your app right here. Like, I'm a big fan of Loki. I think it's a really good tool where you can just chuck data at it and it'll take it as well. But any of these things function as what we call an event bus, or most of them are called event buses, or Kafka is some people call it like an event broker, or but the model is topics being written to by producers and then read from consumers. Let me show you guys one other example. This was a really good one. It's called Wayfair. Telegraph. When Wayfair did Telegraph to InfluxDB, they have a really good kind of visibility thing. And is this the PDF for it? Let's see if this... yeah, this PDF writes up some of the architecture that I've shown you guys in other labs. Let's see if they have it here. This is it right here. And when you look at this architecture, don't think about anything else on here. I'm not trying to trick you guys. I'm not trying to be like, oh, look at this thing. All I'm saying is, look at this bus right here. Remember I told you it's like a little subway or like a little bus in your town that runs around? Kafka is running between Ireland and Boston and Seattle. And Kafka is always ready to write in their environment. And they use Telegraph to throw data in. And then when it comes to here, when they get in Boston, Telegraph reads the data out and throws it to InfluxDB to be looked at, so all their metrics data is actually being written into Kafka, Influx metrics, just data being written. And Kafka has some mirroring and kind of DR and like forwarding capabilities and stuff that make it like a really powerful bus. The guy who, by the way, if you're like, Scott, I need to know more about this and that's a path in my career, the guy that knows this the best that I know is a guy named Stefan Merrick. Stefan Merrick also has like 12 of his AWS certifications, but he has a couple of Udemy courses on Kafka, and he's a master with Kafka. That's what he does professionally. He's a DevOps guy, SRE type guy. You've probably heard of him if you've ever been on Udemy. He's a very popular guy on there. But he has a bunch of courses on Kafka if you want to learn about it. That's about all I can show you on Kafka. I'm the guy down in the engine room just keeping the Kafka running. But anyways, Kubernetes pods are ephemeral, so logs need to go somewhere else. True. All systems. By the way, all systems are like that. I have big heavy duty, servers that have 2 terabytes of RAM on each of my nodes, and they're water cooled. And I've got boxes that have 256 cores and 2 terabytes of RAM on them, right? And those nodes, I still throw the logs off them in real time. And the reason is because if a node ever goes down, I need to know what was wrong before I bring that node back up. Because if it's a security incident and you bring it back up, you might have just game overed your whole environment. And you might say, well, Scott, I would quarantine it, but you didn't know it was a security incident. You thought the box just went down. You can't evaluate logs on a server that's down until the server comes back up, unless you chuck them off in real time, which, by the way, chucking logs off your server in real time to Loki or any other centralized tool like this negates... If you guys have ever seen a cyber kill chain, right? MITRE, right? Attack.MITRE. This is the cyber kill chain. Guys don't get... In the cyber kill chain that most people study and learn, and I would spend some time with this if you don't know it, it's not until way over here. Hold on. Where the hell? Come on. Why can't I move you right? Yeah, here. It's not over until discovery here. It's not until way over here. That's actually... Where the hell is that? Defense evasion. It's not till here that they start trying to get rid of logs and stuff. Well, when you first started scanning my system, and when you first got in, and before you even privilege escalated, and then before you even tried to delete shit, because, you know, you always see, like, the last thing you do is delete all your logs. I don't care. I was getting them in real time. The only log I didn't get was the one when you hit the button. Every other log I already had off. You owned my system, but I still got you. Right? You're like Dave Chappelle going, I got you. That's an old, that's like 20-something-year-old reference now. Anyways, defense evasion. It's him and Oprah. He gets Oprah pregnant, and he doesn't say gotcha. He uses some terms I'm not allowed to use on the interwebs. But look at this. All these things, all the stuff that deals with closing off logs and stuff, you've already got it. You've solved that problem. You haven't solved any other problem, but you've solved that one. All right, anyways, so does anybody want this case study? You guys want me to link this to you? This is a really good read. If you're serious about like how distributed systems talk to each other, you gotta understand event driven. And it's, again, I was talking about this earlier, like people use event driven, like, oh, are we going event driven? Are we being agile? Are we, you know, and it's like this buzzword, and event driven's a big buzzword. But you can use it right, and you can know what it's doing, and then you can be ready to kind of figure any of that stuff out. I'll link this to you guys here. Hold on. Because I really do. This influenced a lot of how I monitor big data systems right here. So, anyways, it's I think it should work for you guys on both sides. But other than that, on the YouTube side, I can't raid or anything, so we'll just drop here. But hopefully this was useful to you guys on the YouTube side. On the Twitch side, let's go find somebody to raid. Let's go raid over somewhere. Let's see who's doing Linux or other system stuff out there in the world. We got BlazeBits on. He's doing some stuff. He's doing Hack the Planet, so everybody wants to do hacking stuff. So we'll go raid him. Hopefully this stuff's useful to you guys. If you want to do a raid message, the raid message is just the do all the Linux. Where's that? Do all the Linux or rage. Where's my rage? I think that pops up for you guys over on the YouTube side. You guys can see it right above my head, I think, the little do all the Linux. All right, we'll go right over there. Hopefully this stuff's useful to you guys. I will see most of you tomorrow night, and I will be on this. I'll be on this weekend as well because the wife's going up to. Where's she going? She's hitting another state, so I think she's going up to New Hampshire or something like that. So, all right, we'll start the raid up. I will talk to most of you guys later on this week. All right, take care.